Yeah, hi everyone, welcome to PrepFusion. So we have been studying about limits. In the last 3 lectures, we have studied about limits and power series, which was also related with limits only. Now, next topic we need to study about continuity. So it is just the extended version of limits only, nothing else. Okay, so let's study about continuity. What is the meaning of a function being continuous at a particular point x equals to a? So when you will say that sir function fx is continuous at x equals to a, what you will do? First of all, you will find out the limit of a function with x tending to a. Okay, you will find out the limit of fx at x tending to a. What does that mean? That means, sir, I need to find out the value of f of a plus and I need to find out the value of f of a minus. Sir, if both of them are coming to be equal, then I would say that limit exists. So this much, sir, I already know. If f of a plus is equals to f of a minus, then limit would exist. Now what I need to do, in this function fx, I simply need to put x equals to a. In this function fx, you simply put x equals to a, the exact value, not a plus, not a minus. Simply put x equals to a. So can I write down it as f of a? Yes, sir. And if this value is coming out to be equal to this particular value, then you would say, yes, sir, function is continuous at x equals to a. This is the definition. What you need to find out? Find out f of a plus, find out f of a minus, and find out f of a, exact a. Okay, f of a plus, f of a minus, and exact a. If all these three values are coming out to be same, then you would say that function is continuous, otherwise it is not. Very simple definition. A plus, a minus, that means you are finding out the limit, and then x equals to a. That's it. If f of a plus is equals to f of a minus, then you would say limit exists. And if f of a plus equals to f of a minus equals to f of a, then you would say that function is continuous. Otherwise it is not. Understandable? Let's just say there is not equal, let's just say this is the scenario. Then also you would say that limit does not exist. Sorry. Then you would also say that function is not continuous. If this is the scenario, then also you would say that function is not continuous. And if this is the scenario, then also you would say that function is not continuous. If you want the function to be continuous at x equals to a, then all three of them should be same. Let's take up this example and it will be completely clear to you. So you need to comment on the continuity at x equals to minus 3, at x equals to minus 2, at x equals to 2, x equals to 4, and at x equals to 5. Okay, and more questions are also there. We will see all the questions, but as of now our target is only question 1. Other questions are also there. We will see them, we will understand the meaning, but as of now you only need to solve, discuss the continuity at x equals to minus 3. First target is at x equals to minus 3. So let me know the values. What is the value of f of minus 3? First let me know this value, f of minus 3. Sir, the value is 1.5. Then let me know the value of f of minus 3 plus. F of minus 3 plus. Sir, f of minus 3 plus. Minus 3 plus means, sir, just ahead of minus 3. So, sir, value is nearly 1.5 only. And, sir, what is the value of f of minus 3 minus? Just before minus 3. Sir, just before minus 3, the value is 1.5 only. Are all of them same? Is this the scenario? Yes, sir. All three values are same only. What does that mean? Function is continuous at x equals to minus 3. That's it. There you go. Understandable? This is the first one. We have solved A. Now second, at x equals to minus 2. Let's talk about at x equals to minus 2. So let me know the value at minus 2. Then let me know the value at minus 2 plus. Okay. And then let me know the value at minus 2 minus. So what is the value at minus 2? The value at minus 2 is, sir, minus 3. You see there is a bubble here and dot here. That means at minus 2 the value is minus 3. The value is minus 3. And what is the value at minus 2 plus? Just after minus 2. Just after minus 2, sir, the value is nearly equals to minus 2 only. And just before minus 2 as well, sir, the value is nearly equals to minus 2 only. Just see it. Just before minus 2, this is the near value which is equals to minus 2. Just after minus 2, the value is nearly equals to this value only, which is minus 2. So these are the scenarios, sir. So here, sir, what do I see is that minus 2 plus equals to minus 2 minus, but not equals to f of minus 2. So this is the scenario I am getting here. What does that mean? Limit exists. Okay, limit is existing. For the condition for the limit to exist, this is the condition for limit to exist. So limit is existing, but it is not continuous. So limit exists at x equals to minus 2, but not continuous at x equals to minus 2. Okay, limit exists, but it is not continuous. Is that understandable to you? Okay, because f of minus 2 plus and f of minus 2 minus are same, but f of minus 2 is different. Okay, let's talk about at 2. So this you can already talk about. Let's talk about at 2. Third one, at x equals to 2. So this you can talk on your own. You need to find out the value of f of 2. You need to find out the value of f of 2 plus. Again, the pen is not working. I don't know why. And writing is not coming that good, no? And then you need to find out the value of f of 2 minus. And all of them you can see that, sir, just before 2, just after 2, sir, just after 2, this is the value, sir. Just before 2, sir, this is the value. So nearly all the values are equals to 1. That means here, sir, limit is existing, also function is also continuous. So directly I am writing down continuous. Okay. Continuous at x equals to 2. So let's keep them in box. Continuous at x equals to 2. Continuous at x equals to minus 3. So here I am writing down not continuous at x equals to minus 2, but limit exists at x equals to minus 2. Okay, limit is existing but not continuous. Option next one, we need to talk at 4 at x equals to 4. So what we need to find out the value? At f of 4 we need to find out the value, f of 4 plus we need to find out the value, and f of 4 minus we need to find out the value. So let's find out these values. At 4 value is nearly minus 1, right? And sorry, at f of 4 the value is exactly minus 1. Just before 4 the value is also nearly minus 1, and just after 4 as well the value is nearly minus 1 only. That means yes, sir, at all these points the value is minus 1. This is also, sir, minus 1 only, and sir, this is also minus 1 only. What does that mean? It is continuous at x equals to 4. Okay, because they are giving the same values. What about next one, which is at x equals to 5, right? Next point is x equals to 5. So let's check at x equals to 5. So f of 5 value is 3. F of 5 value is 3. F of 5, you can see where is the bubble, and here you can see bubble is here and this is the dot. So f of 5 is 3. What is f of 5 minus? That is 2. And what is f of 5 plus? This is f of 5 plus. Just after 5 the value is 3, and just before 5 the value is 2, right? And at 5 the value is 3 only. At 5 value is 3. Just after 5 the value is 3, and just before 5 the value is 2. So now what is the scenario? That, sir, f of 5 plus is not equals to f of 5 minus, right? But f of 5 plus equals to f of 5. So from this particular scenario, what you can say, if this is your scenario, that f of 5 equals to f of 5 plus but not equals to f of 5 minus, again, sir, it is not continuous. Along with that, limit is also not existing, right? What you will say? Limit does not exist. Limit does not exist, and function is not continuous at x equals to 5. Is that understandable to you? Limit does not exist at x equals to 5, and function is also not continuous at x equals to 5. Is that understandable to you? All these points are understandable? Well and good. Now, sixth question is there. Discuss the type of discontinuity. So there are two type of discontinuity. Sixth I am doing type of continuity. Types of continuity. Although it is not that important, but who knows, in the examination they can ask. Types of discontinuity. Sorry, not continuity. I hope discontinuity is written. Yes. There are two kind of discontinuities. Types of discontinuity. Okay. Two kind of discontinuity is there. First one is removable and other one is non-removable. Removable and non-removable. Removable and non-removable. What is the meaning of removable discontinuity? That means limit exists, but surely it is not continuous. That's why we are talking about discontinuity. Basically, if the function is continuous, we will not talk about the type of discontinuity. No. If function is continuous, we will not talk about the type of discontinuity. If function is continuous, we will not talk about the type of discontinuity. So we will talk about the type of discontinuity only when the function is discontinuous. So we already know that function is discontinuous. So I don't need to write down that function is discontinuous. Here the condition is that limit should exist, and non-removable means limit does not exist. Limit does not exist. So which example will come in this scenario? In this scenario, which example will come? In this scenario, example B would come, because limit is existing at x equals to -2, but it is not continuous. So example B would come here. And here which example would come? Sir, limit is also not existing and it is discontinuous as well. That means here example E would come. And here these example D, C and A, they will not come in the discontinuity examples, right? They are asking about the type of discontinuity. That means type of discontinuity will be discussed if the function is discontinuous. But here the function is continuous, I will not discuss. Here the function is discontinuous, yes. Now what I will see? Whether the limit is existing or not. Yes sir, limit is existing, that means it is the removable type of discontinuity. Here function is continuous, I will not talk about the type of discontinuity. Function is continuous, I will not talk about the type of discontinuity. Function is discontinuous here. Now I will see whether the limit is existing or not. So limit is not existing, that means it is non-removable type of discontinuity. In the examination, they can ask the question, they will frame the 4 options in a manner. Option A, at x equals to 2, function is continuous. Option B, at x equals to 4, function is continuous. Option C, at x equals to 5, the function is discontinuous and the type of discontinuity is removable or non-removable, whatever they want to write down. And option D, at x equals to -2, the function is discontinuous and the type of discontinuity is removable discontinuity. Which of the following options are correct? These kind of questions they can frame. Then you should know what is removable and what is non-removable discontinuity. Is that clear to you or not? So if limit is existing, one of the criteria it is satisfying, but other criteria is not satisfying, that means it is removable, otherwise it is non-removable. Sir, what is the meaning of this? Let's just say you design a system. This is your system. Okay, let's just say you have designed a block. Now in these blocks, if someone is saying that, sir, I am applying the input 2, then you would say that, sir, output is coming out to be 1.5. If someone says that I am applying the input to be 0, if I am applying the input to be 0, output is coming out to be 1. So this system you have designed. Now what the user did, user applied x equals to -2. Okay, user applied x equals to -2. What answer came? Answer came, output came as -3. Then what user did, user applied some value greater than -2. So some value greater than -2 he applied, then answer was -2. And then he applied some value less than -2. What was the answer? Answer was -2. So now here the user got angry. Okay, the guy who purchased this device, the guy who made the purchase of this device, he got angry. Why he got angry? Because just after -2 you are giving me different value, just before -2 you are giving me different value, and at -2, sorry, just after -2 and just before -2 you are giving me the same value, but at -2 you are giving me different value. So he got angry. You got to know that function is discontinuous. Then what you did, in this code, whatever the system that you have designed, in this code what you did was, you fixed the value. Basically in this code you made one change, that just as the input is -2, you need to throw -2 only. Actually, when you designed it, it was throwing -3. But what you did, you changed the code of this particular system. You guys would have done it, no? Like a teacher would give you a task, but you would see that, sir, at some particular point I am getting different answer. So what you guys used to do, you will fix that point. ऐसे काम किया ना आप लोगों ने? You guys would have done it in your final year project or somewhere that, sir, working perfectly, but at one point, sir, it is not working. So what I would do, I would fix the input and a certain output I would fix it in the code I will write down. This thing I have also done in my final year project. So it was working at all the values of resistance, but at one particular value of resistance it was not working. So what we did, we changed the code. Okay. So what you did, you changed the code. At other code it will work fine, but at -2 it will give you perfect value of -2 only. This is how you made the code. Basically what you did was, your function will behave normally everywhere, but at x equals to -2, what you did, you fixed the value that should be -2 only. So previously it was discontinuous, but now you could remove the discontinuity. Now after some time, when you have changed the code, now after changing the code, if the user comes, what output he will receive? At -2 plus, -2 only, at -2 minus, -2 only, and at -2 as well, he will receive -2 only. That's why it is known as removable type of discontinuity. Okay, what it is known as removable type of discontinuity. Understandable? Now let's talk about some other point. What is that point? Let's talk about the point x equals to 5. So what the user did, user applied the input. Okay, he applied the input x equals to 5. What output he received? 3 output he received. Then he applied the input just greater than 5. What output he received? 3. Just less than 5. What output he received? 2. Again he got angry that at 5 and 5 plus you are giving me the same value, but at 5 minus you are giving me different value. But this 5 minus, now you thought that, sir, I will change the code. But this 5 minus is not in your control, no. I told you 5 minus is a finite number. 5 minus is a finite number just before minus 5. But you don't know which number it is. So it is not in your control. You cannot find this number. You cannot find 5 plus, you cannot find 5 minus. They have to be same. Then only you can change the code. If there was some issue with f equals to, if there was some issue with x equals to 5, then you could have changed it. What you would have done, you would have fixed some value here. You would have fixed some value. But if 5 plus and 5 minus are not even same, then you cannot do anything. You will say to the user that get me, like, don't give me money and give me my product again. Okay. Basically, there is no solution. So it is non-removable type of discontinuity because 5 minus is not in my control. Is that understandable to you? Although all these things you don't need to remember, I am telling you all these things so that you will be comfortable in the examination. You don't need to mug up the things. Okay, sir, removable type of discontinuity. What is the meaning of removable type of discontinuity? Limit exists or limit should not exist. So these kind of things should not be there in your mind. Removable, that means I can remove it. How I can remove it? Okay, sir, at a plus and a minus I was having the same value. At f of a I was not having the same value. That means, sir, I can change it. But sir, if I am not having a same value at f of a plus as well and f of a minus as well, then sir, a plus and a minus are not in my control because I don't even know where is a plus. I don't even know where is a minus. I only know that a plus is just greater than a, but where it is, I don't know. A minus is just less than a, but where it is, I don't know. So I don't even know these points. So how will I improve my code? Right? So f of a plus, f of a minus, it is not in my hand. That means it is known as non-removable type of discontinuity. Although this much discussion was not required, but still what I want is that you remember the minimum things. That's why I gave you the explanation. Here somewhere you want to write down the explanation, then you can write it. Otherwise, it is fine for you. Just remember the things. Removable type of discontinuity, non-removable type of discontinuity. Removable means limit should exist and non-removable means limit should not exist. Limit is also not existing and function is also discontinuous. Is that crystal clear to you or not? I hope it is completely understandable. So 1 and 6 we have done. Now let's talk about, is the function continuous in closed interval 0 to 4? Okay. Closed interval 0 to 4. Now let me know one thing. Does 1 belong to 0 and 4? Yes, sir. It belongs. Does 2 belong to 0 and 4? Yes, sir. Does 2 plus belong to 0 and 4? Yes, sir. Does 2 minus belong to 0 and 4? Yes, sir. Now I am asking, does 0 belong to closed interval 0, 4? Yes, sir. It also belongs because it is a closed interval. No, it is closed interval. Closed interval means 0 is also included, 4 is also included. 0 plus belongs to 0 and 4. Yes, sir. 0 plus also belongs. But 0 minus does not belong to 0 and 4. No, it does not belong. 0 minus is not even belonging. So what does that mean? That here, sir, 0 is available, 0 plus is available, 4 is available and 4 minus is available, no? Right? 4 belongs to 0 and 4? Yes, sir. Absolutely. 4 plus belongs to 0 and 4? No. 4 plus will be after 4. When I say 0 to 4, what does that mean? Only these values are included. That means 0 plus is included, yes. 4 minus is included, yes. 4 plus is included, no. 0 minus is included, no. So what all values are included? Every value between 0 to 4, taking 0 and 4 as well. So 0 is included, 4 is included. 0 plus is included, 4 minus is included. So if I discuss the continuity, what does that mean? If I discuss that continuity in closed interval 0 to 4, what does that mean? What does this statement mean? It simply means that function should be continuous function should be continuous at all x belonging to 0, 4 in open interval. That means it should be continuous at all the points between 0 and 4, and f of 0 plus should be equals to f of 0. Why is that so? I am not caring about f of 0 minus. Why is that so? Because 0 minus is not even belonging to this guy, no? Are you able to understand this point? And f of 4 should be equals to f of 4 minus. Here I am not even talking about f of 4 plus, because f of 4 plus is not even belonging here. So if I am talking about 0 to 4, what does that mean? That means I need to talk about that 0 and 0 plus and 4 and 4 minus and every point in between them. That's it. I don't need to care about anything else. Is that understandable to you or not? I hope it is completely understand. I hope it is completely understandable to you. And in between 0 to 4, I will care about all the points. So f of 0 plus, all the points, f of 4 minus, f of 4. That's it. 4 plus and 0 minus, I am not even caring. So now this is the question, that between 0 and 4, what is the scenario? This is your x equals to 0 and this is your f of 4. So now you know that, sir, f of 0 is equals to f of 0 plus, that is equals to 1, and f of 4 is surely equals to f of 4 minus, that is equals to minus 1. And in between you can see that graph is completely smooth, like that means graph is not breaking. Here the graph is breaking, no, so that's why it was discontinuous. Here the graph was breaking, no, that's why it was discontinuous. This was discontinuous. This was also discontinuous. But rest at any other point the graph is not breaking between 0 to 4, that means it is completely continuous. Yes. Is the function continuous? Yes. Answer is yes. Is that clear to you? Now they are asking from 5 to infinity. Next is 5 to infinity. Next is 5 to infinity. What does that mean? What is the meaning of 5 to infinity? That means, sir, I need to care about f of 5 and I need to care about f of 5 plus. F of 5 and f of 5 plus. Right? And every point between 5 and infinity. So let's talk about 5 and 5 plus. So what is the value of f of 5? Sir, value of f of 5 I am getting is 3. And what is the value of f of 5 plus? That is also 3. And all the points between 5 to infinity, the graph is smooth only, no? Nowhere the graph is breaking. So graph will keep on going. It is the smooth graph. What does that mean? Yes, it is continuous. Yes, it is continuous. But what someone will think that, sir, at x equals to 5, the function is discontinuous. At x equals to 5, we have seen, no, at x equals to 5, the function is not continuous. So that means, sir, here 5 is included, so answer should be no. That x equals to 5 function is discontinuous, so answer should be no. Wrong. Why is that so? Because if I am talking about the closed interval, I only care about 5 and 5 plus. I don't even care about 5 minus. 5 minus is not my matter of concern when I am talking about the interval 5 to infinity. 5 to infinity means 5, 5 plus and all other points. So at 5 and 5 plus, they are same. So yes, it will be continuous. So if I am saying that my function is continuous between in the closed interval a to b, so can you say that your function would be continuous at x equals to a and at x equals to b? Your answer would be, sir, I cannot comment. Why is that so? Because, sir, if you are saying in your closed interval the function is continuous, that means, sir, you are talking about f of a equals to f of a plus. You are not even making any comment at f of a minus. And when you are saying that function is continuous in the closed interval a to b, that means you are saying that, sir, f of b equals to f of b minus. You are not even making any comment at f of b plus. So, sir, it might be equal, it might not be equal. So I cannot comment on continuity of a and b. Okay. Sir, I only comment one thing. What is that? That it is continuous between all the values of, it is continuous between all the values between a and b. It is continuous for all the values between a and b, and f of a equals to f of a plus, f of b equals to f of b minus. That's the only comment I can make. Is that understandable to you? So in closed interval, open interval, it is very, very important for you to understand. Is that clear to you? Okay. Now they are talking about between minus 5 and minus 2. See the next option, which is fourth one is x minus 5 and minus 2. Minus 5 to minus 2. So do I need to care about f of minus 5? What I mean to say is that, does minus 5 belong to minus 5 to minus 2? No, it does not belong. Does minus 2 belong to minus 5 to minus 2? No, it does not belong. Does minus 3 belong to minus 5 to minus 2? Yes, it belongs. What does that mean? That means I need to care about all the values all the values between -5 and -2. No worries about -5, -5 plus, -5 minus, -2, -2 plus, or -2 minus. Basically, I don't care about -5 and -2. I only care about the values in between. So now if I see this graph, -5, where is -5? This is your -5. This is your -5. Okay, and this is your -2. So between -5 to -2 is the graph continuous? Yes, sir. The graph is smooth, 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 and smooth. Someone would say that, sir, the graph is breaking at -2, sir. So what? The interval is open. Open interval means you don't need to care about this guy. No care about this guy. So from -5, sir, value is continuous only. Here the value is 1.5, value is 1.5. So, sir, everywhere graph is continuous, 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 continuous. Sir, at -2 it is breaking. So what? If it is breaking at -2, no need to care about it, because I don't care about the -2 value. I just care about just before -2. Yes, sir. At everywhere the graph is continuous. So yes, sir, it is continuous. That means, is it continuous? Answer is yes. Answer is yes. Give this answer. Is the function continuous in the interval -2 to 4? -2 to 4. And what is it done? Open interval at -2, closed interval at 4. -2 to 4. -2 to 4. So let me know one thing. What you will let me know? Does -2 belong to -2 to 4? -2 to 4? No, sir. Does 0 belong to -2 to 4? Absolutely, sir. Does 0 belong to -2 to 4? Absolutely, sir. Does 4 belong to -2 to 4? Absolutely, sir. Does 4 minus belong to -2 to 4? Yes, it belongs. Does it belong? Absolutely, it belongs. And does 4 plus belong to -2 to 4? You will say no, sir. 4 plus does not belong. What does that mean? You need to care about all the values between -2 and 4, and f of 4 should be equals to f of 4 minus. That's the only demand you are having. Is that understandable to you? Because 4 minus belong, no? So f of 4 should be equals to f of 4 minus. Here, sir, -2 was not even belonging, so I will not care about -2. -5 was not even belonging, I will not care about it. Sir, -2 is not even belonging, I don't need to care about it. But sir, 4 is belonging, no? So 4 and 4 minus is belonging, so I will care about these two guys only. So if they are same, my job would be done. So if you see this question, okay, you see this question here, f of 4 is equals to f of 4 minus, that is equals to -1. Yes, sir. And from where to where you need to check? From -2 you need to check. So -2, sir, it is not even belonging. Someone would say that, sir, at -2 the graph is breaking. Who cares about it? No one cares about -2. After -2 you see that from -2 to 4 you see that graph is continuous. From -2 to 4 you see that graph is continuous, and at x equals to 4, sir, I can see that f of 4 is equals to f of 4 minus. That means, yes, sir, this condition is also achieved. That means, which condition is achieved? Sir, this condition is also achieved, and this condition is also achieved. That, yes, sir, it is continuous between -2 to 4. At -2 it is breaking, I don't care about it. So from -2 to 4 it is continuous, and at x equals to 4, f of 4 is equals to f of 4 minus. That means, yes, sir, this answer is also correct. What about between -3 to 4? -3 to 4. This is -3 and this is 4. What people will do? Sir, they will say that, sir, at -3 it is continuous, at 4 it is continuous. That means, sir, answer is yes. But you need to check in between the values as well, no? You forgot here, in between the values. It is discontinuous at -2, no? Basically, when I am talking about between -3 to 4, right? When I am talking about -3 to 4. Sixth one is -3 to 4. So someone will say that, sir, I need to care about all the values between -3 and 4. Okay? Along with that, I need to care about one thing, that -3 should be equals to f of -3 plus, and f of 4 should be equals to f of 4 minus. This is what I need to care about. So what people will do is that they will care about this thing only. That, sir, yes, sir, f of -3 equals to f of, what they would say is that, sir, f of -3 equals to f of -3 plus, that is equals to 1.5. And what about 4, sir? Sir, f of 4 equals to f of 4 minus, that is equals to -1. Yes, sir, it is fine. So it is continuous. But You forget about this point. At minus 2 it is not continuous, no? So here what I will say, at x equals to minus 2, at x equals to minus 2, graph is discontinuous. Fx is discontinuous. Discontinuous. So although this condition is achieved, but you should not be caring about only the boundary points. You should be caring about the points in between as well. So this condition is achieved, but the upper condition is not achieved. That means here the answer will be no. It is not continuous between all the values of minus 3 to 4. Although it is continuous at minus 3 and 4, but not continuous at all the values between minus 3 to 4. So at minus 2 it was discontinuous. That's why answer will be no. More questions I can ask. What question I will ask? That is it continuous between 2 to 5? 2 to 5 in this manner. Give the answer. 2 to 5. Sir, 2, 3, 4, sir, everywhere it is continuous. I only need to care about 5. So, sir, 5 belongs here and minus 5 belongs here. 5 also belongs here and minus 5 minus also belongs here. So, at 5 you are getting the value 3. At 5 minus you are getting the value 2. Both are not equal. Answer will be no. It is not continuous, right? Because 5 and 5 minus both belong here. And at 5 value is 3, at 5 minus the value is 2. Both are not same. Both are not same. That means it is not continuous. Okay. So in that manner, I will be able to check the answer. More questions I will ask. Let me ask more questions. From minus 2 to 5. Okay. So I don't need to care about 5. In between all the values, it is continuous. I only need to care about minus 2. So what I will do? Sir, what all belongs? Minus 2 belongs and minus 2 plus also belongs. What is the value at minus 2? The value at minus 2 is minus 3. And what is the value at minus 2 plus? The value is minus 2. Both are not same. That means answer will be no. Okay. So you can write down in your free space, wherever the space is there, you can write down all these points and you can say that they are discontinuous in this interval. So is that understandable to you? Closed interval means closed interval A to B. That means A is included, A plus is included, B is included, B minus is included. That's it. And if open interval is there, I don't need to care about both of the points. I don't even need to see at A plus or A minus or at x equals to A. I don't even need to see at B, B plus or B minus. I don't care about anything else. Only I care about in between points. Is that clear to you? Is the continuity in closed interval, open interval is clear to you? Although it is taught as a separate topic, but I thought that in this question only I can discuss everything. So your 95% of the concept of continuity is done. More than 95. I would say 100% concept is completed. So continuity at a point, continuity in closed interval, continuity in open interval, continuity in open closed interval or continuity in closed open interval, everything is crystal clear. What points I need to check, how I need to check, everything is absolutely clear to you. Say yes or no. Okay. Completely clear. So you should know the meaning of open interval, you should know the meaning of closed interval. The light is gone. No air conditioner. Okay, nothing. And the temperature is 50 degree. So I will have to turn on the fan. Okay guys. So some small amount of voice may come. I will have to turn on the fan. You try solving this question on your own and I will open the fan. Okay. Here options of A are given, but one of the option is also mentioned that not possible, does not exist. So all these kind of options are mentioned. Some values will be mentioned that would be 16. Option B is minus 16. Option D is 4 and option C is 8. Okay, option C is 8. Option D is not possible. Which of the following options are correct? Okay, you need to tell that this particular thing. I will turn on the fan and then I will solve this question. Yeah, so did you solve this question? What was your answer? Let's check out the answer. Okay, so if they are saying that what they are saying, determine the value of A if possible so that the function is continuous at x equals to 0. So they are saying that function is continuous at x equals to 0. What does that mean? They are saying that sir, f of 0 equals to f of 0 plus equals to f of 0 minus. This is what they are saying. Now, do you know the value of f of 0? Yes, sir. Do you know the value of f of 0 plus? No. Do you know the value of f of 0 minus? No. Now, what if I find out the value of f of 0 plus and f of 0 minus and both are different? Then the question itself will be wrong, no? Then the answer would be option D, not possible. Are you able to understand this point? Are you understanding? If f of 0 plus and f of 0 minus are becoming different, then what you will say? Sir, the limit also does not exist and the function is also discontinuous. So but here they are saying that function is continuous, then answer would be option D. So you have to check the value at 0 plus as well and 0 minus as well. So let's find out the value at 0 plus. So what will be the value at 0 plus? That means limit x tending to 0 plus. So at 0 plus what function will be followed? This function will be followed. So at 0 plus this function will be followed, which is under root x divided by 16 under root x minus 4. If you put 0 here directly, if you put, then what you are getting, 0 by 0 form you will get. 0 by 0 form means what you will apply? L'Hopital you will apply. Can you find out the limit? Yes sir, L'Hopital I will apply, and directly I can sense that sir on the upper side 1 by under root 2x would come. Sir here the differentiation would be 1 by 2 under root 16 plus under root x divided by 1 by 2 under root x. So this and this will get cancelled out. Put x equals to 0 here, what answer you will be getting? Put x equals to 0 here. So 8. What is the limit you are getting? 8. So value of f of 0 plus we have got is, here I am writing f of 0 plus we have got is 8. Now let's just say options were somewhat like this: 16, minus 16, 8 and minus 8. That means not possible is not the option. What does that mean? That if you check at f of 0 minus, then also it will come out to be 8 only. But in the examination you don't need to check f of 0 minus, you can directly click on this option. The answer will be 8. Are you able to understand this point? If one of the option is not possible, if one of the option is not possible, then only you will check at 0 plus as well and 0 minus as well. And if the options are 4 different values, or it is a NET type of question, then what you would say, directly you would write down the answer to be 8. Why is that so? Because f of 0 plus is 8 and they are saying f of 0 plus is equals to f of 0, because function is continuous, no? And what is the value of f of 0? The value of f of 0 is nothing but a. So what is the value of a? Value of a is 8. So this is the answer. But if it is mentioned that not possible is also one of the option, then you will have to check what is the value at f of 0 minus. So what is the value at f of 0 minus? So the value at f of 0 minus would be this limit, right? So if I put 0 here, cos 0 will be 1. It is 0 by 0 form. That means you need to apply L'Hopital rule. But again, will you apply L'Hopital rule? You can apply L'Hopital rule if you want, but I can see a standard form here, right? Which standard form? So limit x tending to 0, 1 minus cos some angle divided by the same angle square. Answer is 1 by 2. Do you remember this standard form? So some angle is sir 4x this time. So what I can do? 1 minus cos 4x. Downward what do I need? 4x square I need, right? So this will become 16x square. But here x square is given. So 16x square it will become, that means I will have to multiply with 16 as well. Is that understandable to you? So 16 and 16 will get cancelled out. 1 minus cos 4x divided by x square will give me, this particular thing will give me 1 by 2. So what will be the answer? 1 by 2 into 16, answer will be 8 only. So now you can see that this is coming out to be equals to f of 0 minus as well. That means yes sir, limit exists, function is also continuous, and f of 0 minus is also giving me 8, f of 0 plus is also giving me 8, and the value at f of 0 is a. That means a will be equals to 8 only. So what will be the answer? Answer will be 8. Understandable? Just find out the limit 0 plus 0 minus, and that is equals to f of 0, which is equals to a. So always at the boundary points we will check, like where the definition is changing. Definition is changing at 0. So that's why I checked at 0. What will I get if I check at 1? Nothing I will get, no? F of 1 plus I will get, f of 1 minus, nothing I will get. I need to check where the definition is changing. Definition is changing at x equals to 0. At x less than 0 there is different graph, x greater than 0 there is different graph, and at x equals to 0 there is different graph. So I don't know what will be the nature of the graph, but I know one thing, the graph would look somewhat like this, that here the value will be nothing but 8, and after that what will be the nature, that I don't know. I cannot comment on this nature, but I know that here the value will be 8, that's for sure. Understandable? Let's go to the next question. Okay, so let's make it look a bit more better. So here we did a different calculation, right? And here we did a different calculation, and this was the conclusion that we wrote down. So you will be able to remember, and this was just a simple conclusion that we have used. So yeah, now you will be able to understand what calculation has been done. When you revise, you should have good enough calculation. Okay, this question you solve. Find out the value of lambda such that the function is continuous at x equals to pi by 2. So I will check at pi by 2 plus, I will check at pi by 2, and I will check at pi by 2 minus. What I mean to say is that at pi by 2, at pi by 2 plus, and at pi by 2 minus, all values should be same. Electricity has arrived, so I need to turn off the fan. Okay, just 1 second. Okay, just 1 second. Yeah, so what is the value at x equals to pi by 2? So that is lambda. These values, sir, I don't know as of now. Okay, so let's check at f of pi by 2 minus. If I check at f of pi by 2 minus, which graph I need to consider? X less than pi by 2, that means this graph I need to consider. That means limit x tending to pi by 2 minus 1 minus sin x divided by 1 plus cos 2x. Right? If I put pi by 2 here, it will come out to be 0 by 0 form, because sin pi by 2 is 1, cos pi minus 1, 0 by 0 form you are getting. Then sir, what I will do? I will apply the L'Hopital rule, x tending to pi by 2 minus. What is the differentiation of sinusoid? That is cosinusoid only. And what is the differentiation of cosinusoid? That is sinusoid only, but with the negative sign. And differentiation of 2x will be 2. Now if you put pi by 2, this minus and minus is getting cancelled out. What is the value of cos pi by 2? That is 0. So value you are getting is 0 only. What is the value of cos pi by 2? Cos pi by 2 is 0. Again I am getting 0 by 0 form. Do notice this thing, that if I put cos pi by 2 here, what I am getting? 0. And sin pi is also 0. Again 0 by 0 form. So again I will have to apply the limit. Okay. Again I will have to apply L'Hopital rule. So differentiation of cosinusoid will be minus sin x, and here it will become 4 cos 2x. Now if I put pi by 2, this will become 1 and this will become minus 1. So what is the answer I am getting? 1 by 4. Is that clear to you? Okay. Here if you put pi by 2, so sin pi by 2 is minus 1, and this will become cos pi is also minus 1. Minus 1, sin pi by 2 is 1 actually. Sin pi by 2 is 1, and 1 and another negative sign is there, so this will become minus 1. Here also this will also become minus 1. So minus 1 and minus 1 will get cancelled out. Answer will be 1 by 4. So this value is coming out to be 1 by 4. Okay. F of pi by 2 minus is coming out to be 1 by 4. Let's check at f of pi by 2 plus. F of pi by 2 plus. That means limit x tending to pi by 2 plus I need to check. Okay. So that will be under root 2x minus pi. Here if you put pi by 2, this will become 0 by 0 form. I guess it will give you 0 by 0 form only. Divided by under root 4 plus under root 2x minus pi minus 2. Okay. So you put pi by 2 plus here, what you will see here, I have pi by 2, 0 by 0 form you are getting. That means I can apply L'Hopital rule. And now why I am not going with factorization, why I am going with L'Hopital? Because I know that, sir, on the upper side you will have to differentiate this particular thing, which is under root 2x minus pi. On the downward side, first you will have to differentiate this one, and then you will have to differentiate this much part. That means, sir, whatever I will differentiate on the upper side, I will have to differentiate the same thing downward side as well. So they will get cancelled out. No, what I mean to say is that now I will apply L'Hopital rule. If I apply L'Hopital rule, what I am going to do? Sir, limit x tending to pi by 2 plus. On the upper side, I will have to differentiate d by dx under root 2x minus pi. Right? On the downward side also, I will have to differentiate. Differentiation of this much part, I will have to take these things upward. A bit upward I need to take. Okay. So differentiation of this particular part, which is under root 4 plus under root 2x minus pi, that would be, sir, 1 by 2 under root the same function, which is 4 plus under root 2x minus pi, this same function, and then multiply with the differentiation of this thing, 2x minus pi. Say yes or no? Now I know that, sir, this differentiation and this differentiation will get cancelled out. Differentiation of minus 2 will be 0 only. Understandable? Whatever the part I will be differentiating upper side, the same part I am differentiating downward side as well. Just one extra term would come up. Is that clear to you? And then I just simply need to put the limit. If I put the limit here, this part would become 0. 1 by 4. Here what answer I will be getting? Answer I am getting as 4, not 1 by 4. What is the scenario? Here I am getting the answer as 4, not 1 by 4. So some calculation error I am doing. अरे भाई क्या दिक्कत है? Here if I put the limit, I am getting the answer to be 4, not 1 by 4. What's the scenario? If I do the calculation here, 1 minus x, 1 minus cos 2x, 0 by 0, cos 2x, here you are getting 1 by 4, here you are getting 4. What's the problem? Let me check the question. Yeah, so there is no error in the calculation actually. This is what we are getting. What we are getting? F of pi by 2 plus is coming out to be 4. And f of pi by 2 minus is coming out to be 1 by 4. And f of pi by 2 they are saying as lambda. If you know all these things, what does that mean? It is not even continuous. What does that mean? This thing, it is wrong. So answer will be not possible. Not possible to find. There will not be any lambda where the function will become continuous. Is that understandable? Where there will not be any lambda for which the function will be continuous at x equals to pi by 2. That means the function is discontinuous actually, because f of pi by 2 plus and f of pi by 2 minus is not even coming same. 1 by 4 and 4, they are not even coming same. If they are not even coming same, what does that mean? That means function is actually discontinuous. So answer will be not possible. Option D will be the answer. Okay, there is no such lambda which will make the function continuous at x equals to pi by 2, because f of pi by 2 plus and f of pi by 2 minus is not even coming same. So for sure there will be one option mentioned as 4, other option will be mentioned as 1 by 4. So what guys will do is that they will either some guy will find out f of pi by 2 minus, he will get 1 by 4, he will click on that option. Someone would find out f of pi by 2 plus, he will click on this option. But if someone would have find out both of the values, then he would know that yes, both of the values are not even matching. That means it is not possible for the function to be continuous. That means answer will be not possible. So always take care that both of the values we need to find out if not possible is mentioned. If it is numerical answer type, that means for sure the limit would exist, along with that it will be continuous as well. So only one thing I will find out. But if not possible is mentioned, that means both of the things I will have to find out. Understandable? Solve this question. Find out the values of A, B, C this time. 3 values I am asking. Okay, if the function is continuous, what does that mean? That means they are saying that f of 0 is equals to f of 0 plus equals to f of 0 minus. Do I know the value of f of 0? Yes sir, f of 0 is nothing but b. Do I know the value of f of 0 minus? Let's talk about f of 0 minus. What will be your f of 0 minus? Sir, f of 0 minus will be nothing but limit x tending to 0 minus. Which function I will follow? This function I will follow. 1 plus ax to the power 1 by x. If I directly put here, what I will get? 1 to the power infinity. 1 to the power minus infinity I will be getting. Right? Someone would say that, sir, actually we will get 1 to the power minus infinity. Just 1 second. Yeah, welcome back guys. Sorry for the interruption. Actually, some call came. It was very important actually. Yeah. So what I was saying, that if I put 0 minus here, so what you will get? A into 0 will be 0. 1 to the power minus infinity you will get. So 1 to the power minus infinity is equals to 1 to the power infinity only. What I mean to say is that, let's just say 2 to the power minus 4 is there. What does that mean? It is 1 by 2 to the power 4. So can I write it down? 2 to the power minus 1, 4. Right? So similarly here, can I write down 1 to the power minus 1, infinity? And what is 1 to the power minus 1? 1 to the power minus 1 will be 1 by 1, that is 1 only. So it is nothing but 1 to the power infinity only. So 1 to the power minus infinity or 1 to the power infinity, both are the same things. Is that understandable to you? Absolutely, sir. So now next what I need to do? I need to find out its limit. You know that what will be its limit? Its limit will be, sir, e to the power l. What is l here? L is nothing but a limit x tending to 0 plus the same limit. This power comes in front, 1 plus ax minus 1. Now you know that this and this will get cancelled out, x and x will get cancelled out, answer is coming out to be a. So what is the answer you are getting? E to the power a. What does that mean? F of 0 minus is coming out to be e to the power a. So here I am putting f of 0 minus is coming out to be e to the power a. That means e to the power a equals to b. Okay, but they are not enough to find out the values. Let's find out, let's do something about f of 0 plus. Let's do something about f of 0 plus. What is the meaning of f of 0 plus, sir? Limit x tending to 0 plus. Which function I will care about? This function I will care about. X plus c to the power 1 by 3 minus 1 divided by x. Now if I put directly x equals to 0 here, sir, what I will be getting? C to the power 1 by 3 minus 1 divided by 0. Now I know that, sir, if limit exists, it has to be a 0 by 0 form. If limit exists, it has to be a 0 by 0 form, because in the limits we have studied this kind of topic that, sir, if it is a 0 by 0 form, then only you can find out the limit. If it is not 0, let's just say it is 2. So 2 divided by 0, answer would be infinity. Then you would say limit does not exist. So if the limit is existing, it has to be a 0 by 0 form. That means c to the power 1 by 3 minus 1 has to be equals to 0. That means c has to be equals to 1 only. So this is the answer we are getting, that c is nothing but 1. So c equals to 1. So c has to be equals to 1. Then again let's find out f of 0 plus. So if I find out f of 0 plus, in place of c I will put 1 only. What is that? X plus 1 to the power 1 by 3 minus 1 divided by x. Okay, and limit surely x tending to 0 plus. Limit x tending to 0 plus. Now sir, if I put this 0 here, what answer I will be getting? 0 by 0. That means sir, now I can apply L'Hopital rule. So upper side differentiation, downward side differentiation. 0 plus upper side differentiation will give me 1 by 3 in front, x plus 2 to the power, x plus 1 to the power minus 2 by 3. 1 by 3 comes in front, 1 by 3 minus 1 will be minus 2 by 3. Understandable? And downward differentiation of x will give me simply nothing but 1 only. Differentiation of x will be 1. Now if I directly put the limit, what answer I am getting? Sir, 1 by 3, 0 here, 1 to the power minus 2 by 3. So what is the answer we are getting? 1 by 3 only. So what we can see here? Sir, f of 0 was nothing but b, which would be equals to f of 0 plus. Why is that so? Because they are saying that it is continuous, so it would be equals to f of 0 plus, which is coming out to be equals to 1 by 3. That would be equals to f of 0 minus, which is nothing but a to the power a. So from here what you can see, sir, b is coming out to be 1 by 3. A to the power a is coming out to be 1 by 3. What does that mean? A will come out to be minus ln 3. A is coming out to be minus ln 3. And what is the value of c we are getting? The value of c, from here only you can see that value of c is coming out to be nothing but 1. There you go. These are your 3 answers. Very intelligently, all the concept of limit is used. Every concept of continuity is also used here. So directly put f of 0 minus, you check. You go to know 1 to the power infinity, you find out the value e to the power a it is. The limit is e to the power a. Here value b is given. Here for finding out the limit, it has to be 0 by 0 form. That means c has to be 1. Understandable, sir? Very straightforward, sir. Now, sir, what I did was, then I find out the limit came out to be 1 by 3. That means b has to be equals to 1 by 3. Now e to the power a equals to b, that means e to the power a has to be equals to 1 by 3. So a is coming out to be minus ln 3. There you go. Very straightforward. This was an important point, that it was 1 to the power minus infinity or 1 to the power infinity. Both are the same thing here. Okay. This was an important point which you understood, and you find out the limit here. Is that clear to you or not? Absolutely, sir. Completely clear. Let's go to the next question. You need to find out the value of a and b so that the function is continuous in 0 to pi. It is continuous in 0 to pi. What does that mean? That means, sir, f of 0 would be equals to f of 0 plus. Right? 0 to pi closed interval is there. And f of pi would be equals to f of pi minus. And sir, it is continuous in, it should be continuous in every value between 0 to pi. Is that understandable to you? Now f of 0 will be equals to f of 0 plus. That means you will be talking about this function only. If I talk about f of 0 and f of 0 plus, that means I will be talking about this function only. But I need to find out the relation between a and b. So what do? Basically, I need to find out the relation between a and b. So I know one thing, that a function is continuous at x equals to pi by 4. At x equals to pi by 4, function is continuous. Right? What does that mean? That means I know that f of pi by 4 would be equals to f of pi by 4 minus would be equals to f of pi by 4 plus. Say yes or no? So f of pi by 4 and f of pi by 4 plus is lying in the same function, but f of pi by 4 minus is lying in the different function. So wherever the definition is changing, no, I will care about those things. So what will be the value of f of pi by 4 minus? That will follow this definition. So here I will simply put pi by 4 plus a into under root 2 sine pi by 4. Say yes or no? Pi by 4 minus will follow this definition. Sine pi by 4 is 1 by under root 2. So answer is coming out to be pi by 4 plus a. Right? Sine pi by 4 is 1 by under root 2. So answer is coming out to be pi by 4 plus a. And what will be the value of f of pi by 4? So that will be nothing but it will follow this particular function. So 2 into pi by 4 multiply with cot pi by 4 plus b. Cot pi by 4 is 1. So pi by 2 plus b. That's the answer we are getting. Is that clear to you? Here you put pi by 4, so this will become pi by 2. Code pi by 4 is 1, so pi by 2 plus b. So from here what you can see, if both are same, if both are equal, so from here what I can see is that pi by 4 plus a equals to pi by 2 plus b. So a minus b is coming out to be equals to pi by 4. This is the first equation we have got. But it is not enough. One more equation we need. So where I will check now? I will surely check at pi by 2 because here the definition is changing. So at x equals to pi by 2, I know that function is continuous. At x equals to pi by 2, function is continuous. So here the definition is changing. So what I will do? I know that, sir, since it is continuous, then this will be the scenario. This will be the scenario. Right? So can I find out the value of f of pi by 2? Absolutely, sir. What will be f of pi by 2? This function will be followed. That means 2 into pi by 2, code pi by 2 plus b. What is the value of code pi by 2? Code pi by 2 is 1 by tan pi by 2. 1 by tan pi by 2 is infinity. That means it is 0. So answer is coming out to be b. So f of pi by 2 is coming out to be b only. Okay, code pi by 2 is nothing but 0 only. Understandable? So answer is coming out to be b. And can I find out the value of f of pi by 2 plus? Why I am interested about pi by 2 plus? Because at pi by 2 plus the definition is changing. This definition will be followed. So a into cos 2 into pi by 2 minus b into sin pi by 2. So sin pi by 2 is 1 and this is cos pi is minus. So minus a minus b, right? Cos pi is minus 1, no? So minus a, and here you will put sin pi by 2 which is 1. So minus a minus b. So this is your pi by 2 plus. So pi by 2 plus is coming out to be minus a minus b and pi by 2 is coming out to be b. What does that mean? That b is minus a minus b. So from here what do you see? That 2b is coming out to be equals to minus a. 2b is coming out to be equals to minus a. Another function was there, a minus b equals to pi by 4. A minus b equals to pi by 4. Okay. So what is a here? A is nothing but minus 2b. Okay. Or what I can do? From here a is nothing but minus 2b. So this will become minus 3b equals to pi by 4. So from here b is coming out to be minus pi by 12. And if b is minus pi by 12, then a is nothing but, here you put a minus pi by 12. And this will be minus a. A and a get cancelled out. A is coming out to be pi by 6. So a is nothing but pi by 6 and b is nothing but minus pi by 12. These are the answer. Did you understand this point or not? Did you understand this question or not? Okay. So where the definition is changing, they are our matter of concern. That I will check at pi by 4 minus. Answer is coming out to be pi by 4 plus a. I will check at pi by 4 plus. Then answer is coming out to be pi by 2 plus b. Then I will check at pi by 2 minus. The answer is coming out to be b. Then I will check at pi by 2 plus. The answer is coming out to be minus a minus b. Then minus a minus b will be equals to b only. That means 2b would be equals to minus a. Okay. So 2b equals to minus a, and here we are already having the relation that a minus b equals to pi by 4. This relation we are already having. Right. So a minus b equals to pi by 4, then 2b equals to minus a, that means a equals to minus 2b. Here I put minus 2b, b is coming out to be minus pi by 12. If I put minus pi by 12 here, the answer is coming out to be pi by 6. So a is pi by 6, b is minus pi by 12. That's it. So this is how we need to think. All these questions are very straightforward if your concept of limit are clear. So differentiability and continuity, both topics are related with the limits only. Everything is related with limits only. Okay. Let's solve this question. Discuss the continuity of fx, which is mod of x plus 1 multiply with mod of x plus mod of x minus 1. First let me know, can you draw the graphs of these functions? Can you draw the graph of mod of x plus 1? Yes sir, I can draw the graph of mod of x plus 1. Sir, this is the graph. Sir, how I can draw it? In the basics, sir, you have taught me. Mod of x plus 1, you need to find out where the function is becoming 0, and at that function I need to make v. Where the function is becoming 0, this function is becoming 0 at minus 1. Sorry guys, the function is becoming 0 at minus 1. So let me do something. Function is becoming 0 at minus 1, no? Right? Not plus 1. So it is minus 1. And then at minus 1 I will make the v. This is the graph of mod of x plus 1. Can you draw the graph of mod of x? Absolutely, sir. Very straightforward. Mode of x graph also I know. And can you draw the graph of mode of x minus 1 as well? Absolutely, sir. Mode of x and mode of x minus 1, it is becoming 0 at x equals to 1. Right? Are both of them, are all these three graphs continuous or not? What I am asking is that, are these three graphs continuous or not? Yes, sir, it is continuous. Completely it is smooth, no? There is no issue. The graph is smooth. Nowhere the graph is breaking. Nowhere the graph is breaking. Nowhere the graph is breaking. So yes, all three are continuous. All three are continuous. Now what you are doing is that you are multiplying and adding these functions. Then their multiplication and addition will surely be continuous only. No. Are you able to understand this point? Basically, what I do is that I will add both of them. So some values will be added. Like here the value is 1, right? At x equals to 0, here the value is 1. Here the value is 0. So 0 plus 1, it will become 1 only. This value will become 1. And here what is the value? Here the value is also 1. So 1 plus 0 will be 1 and then multiply with 1. So the value will come out to be 1. I don't know what kind of nature of graph it will have, but it will never be discontinuous. No. The graph will never break. Are you able to understand this point? So what I am saying is that if fx is continuous and gx is continuous, then fx plus gx will be continuous for sure. What I am saying is that if fx is continuous and gx is continuous, then fx plus minus gx will be continuous for sure. Do you agree to this point? Because you are simply adding up the values. No value will tend to infinity when the graph breaks. Let's just say the graph is go somewhat like this, or you would have seen the graph of 1 by x. So graph is breaking at x equals to 0, value is tending to infinity, then the graph would break. No, but if you just add up some values, how the graph would break, right? And if I multiply both of them, so what? This will also be continuous only. Basically, let's just say this value is 2, this value is 5, so 2 multiplied with 5 will give you 10. No issue there. But if you do the division, then there is a problem. So here they are in addition, then they are in multiplication, that means it will be continuous only, that's it. But if you do the division, then there is a problem. Why is that so? If I do fx by gx, why it is a problem? Look, let's just say this is your fx and this is your gx. So at x equals to 0, this guy is throwing value 1, and at I am talking about at x equals to 0. So this guy is throwing value 1 and this guy is throwing value 0. So at x equals to 0, what will be your value? Value will be infinity. So here your graph may break. So it may be continuous, it may be discontinuous as well. So here what I can write down, here I will write down that may be discontinuous. May be discontinuous. So you don't need to mug it up. You can simply think that, sir, what if this gx becomes 0? If this gx becomes 0, then fx by gx will be nothing but tend to infinity. And since it is tending to infinity, then sir, what will happen is that the graph will be discontinuous. But here, sir, if this becomes 0, then total graph will become 0 only. If it is 1, it is 2, it will be 2 only. If 3, 4, it will be giving you a certain value. Sir, here if it is 3, it is 4, then it will give you 7 or minus 1, whatever it is. So addition, subtraction and multiplication will surely give you continuous, but the division may be discontinuous. But here addition and multiplication is there, that means this graph is continuous only. Always continuous between minus infinity to infinity. Continuous between minus infinity to infinity. Is that clear to you? Understandable? Well and good. Let's go to the next question. You'd let me know where the signum x is discontinuous. Sir, if I talk about these values from here to here, it is completely continuous, sir. Here if I talk about these values, sir, graph is smooth, everywhere it is continuous. But sir, at x equals to 0, what I mean to say is that signum 0 plus is equals to 1. Signum 0 minus, it is equals to minus 1. And signum 0 equals to 0. All three values are different. That means this function is discontinuous at x equals to 0. Let's use different color of pen. This is discontinuous at x equals to 0. What about this guy? Check at any integer. Check at f of 1. What is the value of f of 1? Sir, f of 1 is 1. This is your greatest integer function. No, f of 1 is 1, sir. What is f of 1 minus? Sir, 1 minus just before 1, it will give me the value 0. And what is f of 1 plus? So just after 1, it will give me the value 1. So is it continuous? No. That means at x equals to 1 it is discontinuous, at x equals to 2 it is discontinuous, at x equals to 3 it is discontinuous, at x equals to -1 as well it is discontinuous, at x equals to 0 as well it is discontinuous, at x equals to -2 as well it is discontinuous. That means it is discontinuous for all x belonging to integer, all x belonging to integer. And what about this guy, greatest? This is your what do we call it, fractional part of x. So fractional part of x, again you can see that it is discontinuous at the integer only. What I mean to say is that what is the value of f of 1 plus? Sir, f of 1 plus, just after 1 the value is nearly 0. And what is the value at f of 1? Sir, the value is 0 only. And what is the value of f of 1 minus, just before 1? F of 1 minus just before 1, the value is nothing but 1. This value is 1 only. Are they same? No. That means it is just discontinuous for every x belonging to integer. For every x belonging to integer. Is that clear to you? So signum is discontinuous at x equals to 0. Greatest integer function is discontinuous at x belonging to integer, and fractional part of x is discontinuous at x belonging to integer only. So here function and their point of discontinuity, signum is discontinuous at x equals to 0. They are continuous at all the integers. Is that clear to you? So now if I talk about signum of fx, signum of fx, what I am talking about? Signum of fx I am talking about. So what might be my point of discontinuity? Where your fx is becoming 0. Where your fx becomes 0, this is the point of consideration. What I am saying? Point of consideration or point of concern. It might happen that wherever fx is becoming 0, this signum fx may be discontinuous. What do you mean by signum fx? That signum of x square plus 2x plus 1. This is what I mean by signum fx. So where this function becomes 0, at that particular point signum can throw some discontinuity. We will see the example, it will be clear to you. So your point of consideration would be all the points where this fx is becoming 0. If I talk about greatest integer function of fx, then your point of consideration would be every point where fx is integer. And if I talk about the fractional part of fx, then your point of consideration would be every fx where it becomes integer. Say yes or no. So I just wanted to let you know the point of consideration, nothing else. We will solve the numerical, it will be clear to you. We will solve the question, it will be clear to you. So do you understand where signum x is discontinuous? Sir, at x equals to 0. Do you understand where greatest integer function is discontinuous? Sir, at x equals to integer. And do you understand where fractional part of x is discontinuous? Sir, at x equals to integer only. And if there is some function mentioned inside, then I will check at fx equals to 0 in case of signum, and in case of greatest integer and fractional part when they are becoming integer only. Understandable? Let's see some question, it will be clear to you. So it is a MSQ type of question. You need to find out if fx equals to signum 2 cos x plus a is continuous for all x, then find out which couldn't be the value of a. That means out of these 4 options, which is not a possible value of a. This is what they are asking. So our function is signum of 2 cos x plus a. How it will be defined? So that it will be equals to plus 1 if 2 cos x plus a equals is greater than 0. So it will be equals to 0 if 2 cos x plus a equals to 0, and sir it will be equals to minus 1 if 2 cos x plus a is less than 0. Is that clear to you? Okay. And where it will be discontinuous, and you can directly see it will be discontinuous when this function will be discontinuous when 2 cos x plus a is equals to 0. It will be discontinuous when this function becomes 2 cos x plus a is becoming 0. Is that understandable to you or not? Say yes or no. When 2 cos x plus a becomes 0, at that time it will be discontinuous, because at 0 it is changing the definition. Greater than 0, plus 1, less than 0, minus 1. So this is the scenario we are getting. So now let's take option A, which is 2 cos x plus 1 by 2. So can it ever be equals to 0? Is it possible? Is it possible that 2 cos x plus 1 by 2 is becoming 0? Yes sir, it is possible. It is possible when cos x become minus 1 by 4. So at all the points where cos x is becoming minus 1 by 4, this particular equation will be true. What does that mean? That means this is not acceptable. They are saying that it is continuous for all x, continuous for all x, but at the point where your x is becoming cos inverse minus 1 by 4, all those points your fx will be discontinuous. Fx will be discontinuous. But what they are saying is that you need to find out the value of a in a manner that the function is never discontinuous for any value of x. But yes, I am able to find out the value of x. Sir, if you get a cos x equals to minus 1 by 4, then this will come out to be 0. This particular thing will come out to be 0. And then, sir, if it is coming out to be 0, then signum 0 will be discontinuous. So my target is that this signum 0 should never be achieved. This is never achieved. This is my target. This should never be achieved. Signum 0 is never achieved. Let's take the next option, which is option B. 2 cos x in place of a I will put minus 1 by 2. So 2 cos x in place of a you put minus 1 by 2 equals to 0. Is it achievable? Is it achievable? Yes, sir. Cos x equals to 1 by 4. Absolutely, sir. It is completely achievable. It is completely achievable. That means, sir, at all the points when my x is becoming cos inverse 1 by 4, at all those points my function will be discontinuous. At all these points function will be discontinuous. Okay, at all those points. So this is also not acceptable. Let's check option C, which is 2 cos x in place of a I need to put 3. Okay, what I need to do is that I need to add a page. 2 cos x in place of a I need to put 3. Okay, so is it achievable or not? Can I get signum 0 if a is equals to 3? So 2 cos x is equals to minus 3 by 2. Is it achievable? You know that, sir, cos x value is between minus 1 to 1 only. This value is between minus 1 to 1 only. Never achievable. Never achievable. What does that mean? That means, yes, sir, if your a is equals to 3, then, sir, this function can never become 0. No matter whatever the value cos x is taking, no matter whatever the value of x you take, if your a is equals to 3, then this particular function can never become 0. If this function is never becoming 0, that means, sir, signum 2 cos x plus 3 I put, take any value of x. Always this function will be greater than 0 only. Greater than 0, or, sir, whatever the value I get, I don't care. I am pretty sure that this function will never be equals to 0. That I can guarantee, sir. I can guarantee, sir, that, sir, this function will never be equals to 0. And if this function is never equals to 0, then your job is done. Understandable? Okay. Right? So never achievable. That means, yes, value of a you could put as 3. What about the next option? So 2 cos x in place of a I need to put minus 3. Is it achievable? So cos x has to be equals to 3 by 2. Is it achievable? Ever? Never achievable. What this is? Sir, this is never ever achievable. So if it is never achievable, then this value will also be accepted. So these kind of questions can be asked in the examination. Is that understandable to you? So what did you understand? That our target is that 2 cos x plus a should never be equals to 0. That means cos x should never be equals to minus a by 2. This is our target. This is our target. And now I know that cos x can be between minus 1 to 1 only. Between minus 1 to 1 only. Right? That means if I say that cos x is equals to minus a by 2, so here I am putting minus a by 2. Minus 1 to 1 only. Then what I am doing is that I am multiplying with 2 on, I am multiplying with minus 2 on all the side. So if I multiply with minus 2, what I get? This 2. So if your a is between minus 2 and 2, if your a is between minus 2 to 2, then yes, signum 2 cos x plus a will be maybe discontinuous, will be discontinuous. Basically it will be discontinuous, otherwise it will not be discontinuous. So every value between minus 2 to 2, every value between minus 2 to 2 will make it discontinuous, and rest all the values will not make it. You can think, no, very easily you can think. What I said was, our requirement was that 2 cos x plus a should not be equals to 0. Then I put 2 cos x plus a equals to 0. So if I put 2 cos x plus a equals to 0, that means cos x will come out to be minus a by 2. Cos x is coming out to be minus a by 2. So from here, range of a is coming out to be between minus 2 to 2. So if your a is between minus 2 to 2, then the signum 2 cos x plus a could be equals to 0. Sorry, this particular value could be equals to 0, and if this value is equals to 0, then there is a problem. The function would be discontinuous. So whenever you see signum and if you want to avoid discontinuity, then this should never come out to be 0. So I always want that this should never be equals to 0. But here if I put this equals to 0, yes, it could be equals to 0. If I put this equals to 0, yes, it could be equals to 0. But if you put this equals to 0, you would say that it is never ever possible. Cos x can never take the value minus 3 by 2. Cos x can never take the value 3 by 2. So it is never achievable. That means these values of a will be accepted and these will not be accepted. Understandable? Say yes or no. Absolutely clear, sir. Let's go to the next question. Find out all possible points where fx is discontinuous. This is your greatest integer function. Okay, this is your greatest integer function. Find out all the points. How many points are there such that x belonging to 0 to 2 pi? Basically what I need to do is that I need to draw the graph of 2 cos x. First I will draw the graph of 2 cos x. Let's draw the graph of 2 cos x between 0 to 2 pi only. Between what points? 0 to 2 pi only. 2 cos x between 0 to 2 pi. Okay, so what I am doing, I am drawing the graph. Let's array bhai. This is how you draw the graph. Between 0 to 2 pi. Say yes or no. Okay, this point is pi by 2, this point is 2, this value downward is minus 2, and this value is 2 only, right? This is the scenario, right? Somewhere the value will be 1 as well, no? Somewhere the value will be 1 as well. At both of these points the value are 1. I don't know whatever the angle is there, I don't care about the angle. Although I can find out the angle will be nothing but pi by 3, right? And this is 90. Yeah, pi by 3 would be the angle, because 2 cos pi by 3 is what? Cos pi by 3 is 1 by 2. So yeah, angle will be pi by 3. Okay, and what this angle will be? This is 2 pi minus pi by 3. So this will be 5 pi by 3. Right, because cos 2 pi minus pi by 3 will also be equals to cos pi by 3 only. Right, so this will be the scenario. Here the value will be 1, and somewhere the value will be minus 1 only. Somewhere the value could be minus 1 as well. Why I am caring about the values minus 1? This value is minus 2. Why I am caring about all these integer values? Because I know that, sir, if greatest integer function is there, no, so I will be caring about this function 2 cos x becoming integer. I will be caring about these functions becoming integer. These functions becoming integer. So where they will become integer? Sir, here at this point it will become integer. What will be this point? What will be these points? So it will be simply pi by 2 plus pi by 6, right? Pi by 2 plus pi by 6. So 2 pi by 3. This point will be 2 pi by 3. Basically this is 90 plus 30. So it will be 120 degree, because cos 90 plus 30 will be sine 30 minus sine 30, and sine 30 is 1 by 2. Yeah, so yes, 120 degree angle it is. And what will be this angle? What will be this angle? So this angle is, next angle is 3 pi by 2 minus pi by 6. So 6, 9 pi minus pi, 8 pi by 6. So this will be 4 pi by 3. This angle will be nothing but 4 pi by 3. Okay, although these angles are not a matter of concern, you just need to find out these values. Now you know that if cos x is throwing value between 2 to 1, at where I need to check the continuity between 0 to 2 pi, right? Value of x is between 0 to 2 pi. Now you see when your x belongs to 0 to pi by 3, 0 to pi by 3, what will be the scenario? When x is equals to 0, what will be the scenario? When x equals to 0, when x is equals to 0, then value of cos to 0, that will be equals to 2 only. So here it will throw the value 2 only. If x equals to 0 plus I talk about, what will be the scenario? 2 cos 0 plus, this value will be somewhat lesser than 2, no? Somewhat lesser than 2. It could be 1.999999 something. So what will be the answer here? 1. Is that clear to you? At x equals to 0 plus I am talking about. At x equals to 0 plus. Is that understandable? And this is your 2 pi. This is your 2 pi. So first I am talking about the boundary points. First I am talking about the boundary points. Why is that so? Because if I say my x is belonging to 0 to 2 pi, then what all points will be my matter of concern? Sir, first matter of concern would be all the points between 0 and 2 pi. Then sir, matter of concern will be 0 and 0 plus. And then sir, matter of concern will be 2 pi and 2 pi minus. And here what points I will care about? All the points where the function is becoming integer. So at 0 and 0 plus, I got to know that yes, there is some discontinuity. Now let's check at 2 pi and 2 pi minus. At x equals to 2 pi, what will be the value I will be getting? Sir, 2 cos 2 pi. Exact value you will get is 2 only. Exact value I will get is 2 only. But at 2 pi minus, what will be the scenario? At 2 pi minus, just before 2 pi, the value is just lesser than 1. Just lesser than 2. That means it would be somewhat 1.9999. So answer will be 1. So here at 2 pi, the value is, at x equals to 0, the value is 2. But just after that, the value has become 1. So can I draw the graph of fx now? I am trying to draw the graph of fx. What kind of graph of fx I will get? So let's talk about the value at 0. At cos 0, the value was 2. This value was, I am drawing the graph of fx. This value was nothing but 2. The value was 2. But just after that, what really happened? Just after that, what really happened? Between 0 to pi by 3, between 0 to pi by 3, between 0 to pi by 3, what is the value we are getting? The value is greater than 1 and lesser than 2. Greater than 1 and lesser than 2. So what value you will get? You will get the value to be nothing but 1. Okay, this much practice you are already having. You will get the value to be nothing but 1 only. And at pi by 3, what will be the scenario? At pi by 3, sir, exact value is 1 only, so I will get the value to be 1. Now, after pi by 3, what will happen? Between pi by 3 to pi by 2, let's talk. After pi by 3, what will happen? Sir, after pi by 3, the value is just lesser than 1. Just less than 1. Here, sir, at this particular point, the value is 0.9999. That means, sir, the value will fall down to 0. So, sir, till this point, the value will be falling down to 0 because the values are between 0 to 1. Greater than 0, less than 1. What does that mean? The value will fall down to nothing but 0 only. And at pi by 2, what is the scenario? At pi by 2, sir, value is exactly 0. So, sir, it will be falling down to 0 only. Is that understandable to you? But at pi by 3, the value was 1. So, here I will make a bubble. At pi by 3, the value was 1. No. At pi by 3, exact value was 1. So, greatest integer function of 1 will be 1 only. But after pi by 3, the value has fallen down to 0. Is that clear to you? Now, sir, just as this has started getting negative, just as it has started getting negative, just after 0, what will be the scenario? The value will be, sir, minus 0.0001, and sir, just lesser integer will be minus 1 only. So now the values will fall down to minus 1 between pi by 2 to 2 pi by 3. Understandable? I hope you are getting the point. Between pi by 2 to 2 pi by 3, the value will fall down to minus 1. But at exact pi by 2, the value was 0. So what I will do is that I will make a bubble here. And here also I should make a bubble. Why is that so? Because here the value was actually 2. Understandable? Then here I am making a bubble. Then here I am making a bubble. Now where the values will fall? After 2 pi by 3. The values will become minus 1.0001. That means they will fall down to minus 2. So what this value will be actually? This value will be nothing but pi. Okay. This value will be nothing but pi. Understandable? Okay. So this is the middle point, which is pi. So from 2 pi to pi, from 2 pi to pi, the value will fall down. This is your minus 1, no? This is your minus 1 and this is your minus 2. The value will fall down here. But at exact 2 pi by 3, the value was minus 1. So here I made a bubble and this is how the graph is going. Now next graph, further graph you can predict on your own, where the definitions would be changing at 4 pi by 3, 5 pi by 3 and 2 pi. So all these points, the definition would be changing. Oh yeah, भाई line बड़ी नहीं हो रही है यार. हो गई. Yeah. So at all these points definition would be changing. Definition would be changing here at 4 pi by 3. Then I will see at 5 pi by 3 and then at pi. 5 pi by 3 and then at pi. Sorry, 2 pi. So between pi to 4 pi by 3, just a lesser integer would be -2 only. So yeah, here the definition is not changing. What I mean to say is that between 2 pi by 3 to 4 pi by 3, the definition is not changing. Look at it very carefully. What will be the value at pi? What will be the value of 2 cos pi? That will be, sir, -2. If you calculate at pi plus as well, the value is just greater than -2. Value is -1.999999. So what will be the answer? You will be getting -2 only. Are you able to understand this point? So at pi there is no discontinuity. Basically between these 2 pi by 3 to 4 pi by 3, the graph is like this. All the values are between -2 to -1. So all of them will throw the value to be equals to -2 only. So here the values will be thrown to -2 only. This was the important point. Here there is no discontinuity. The definition is not changing here. This is how you are getting the graph. And at 4 pi by 3, what will be the value? 4 pi by 3, the value will be -1. At 4 pi by 3, the value will be -1. See it very carefully. If you can see the graph carefully, then you will be able to know. Now between 4 pi by 3 and this point, what is this point? This point will be nothing but, sir, this point I will have to mark. This point will be nothing but 3 pi by 2. Okay. So between 4 pi by 3 to 3 pi by 2, I have to mark 3 pi by 2. Till that point, the values will be thrown to 4 pi by 3 to 3 pi by 2. Now let's just say the value will be -0.99999. That means it will throw to -1 only. So the values will be thrown to -1 only. The values will be thrown to -1. But at exact 3 pi by 2, the value will become 0. Then from 3 pi by 2 to 5 pi by 3, the values will be thrown to 0 only. In this window, the values will be thrown to 0 only. Okay. And but at exact 5 pi by 3, the value will become 1. Here the value will become 1. Basically, the graph is going like this. If these are the values, then what is the answer you are getting? If the values are between 2 to 1, the answer I am getting is 1. Where the graph is breaking, that you need to take care. Then if these are the values, then what answer I am getting? I am getting the answer to be 0. Getting the answer to be 0. Where the graph is breaking, that you need to take care. Then I am getting the answer to be -1. Then I am getting the answer to be -1. And after that I am getting the answer to be, in this range I am getting the answer to be -2. Then I am getting the answer to be -2. Then again, sir, in this range I am getting the answer to be -1. In this range I am getting the answer to be -1. Then, sir, in this range I am getting the answer to be 0. And then, sir, again in this range I will get the answer to be 1. Next will be between 5 pi by 2 to 5 pi by 3 to 2 pi. 5 pi by 3 to 2 pi, I will get the answer to be 1 only. But the graph will break here. Why is that so? Why I am making a bubble? I am making a bubble because, sir, I know one thing. What do I know, sir? I know one thing is that at 2 pi by cos 2 pi, exact value is 2. I have checked, the exact value is 2. So the graph has broken at 1 point, 2 point, 3 point. Basically here it is broken 1, 2, 3, 4, 5, 6, 7 and 8. So what is the total number points? The answer is nothing but 8. This is the answer. But I am asking you one question now. It is becoming discontinuous at all the points where 2 cos pi is integer? I am asking one thing. The function is becoming discontinuous at all the points where 2 cos pi is integer. Is that statement correct? Or 2 cos x is integer? What I am saying is that the function is becoming discontinuous at all the points where 2 cos x is integer. Is that statement correct? No, sir. When 2 cos x was -2, at that point it is not discontinuous. What I mean to say is that what is the value of f of pi plus? Sir, f of pi plus, the value is okay. Yeah. What is the value at f of pi plus? Sir, f of pi plus, the value is -1.9999 something, which will be dropped down to -2 only. What is the value of f of pi minus? Sir, -2 only. And what is the value of f of pi? So that is also minus 2 only. So yes, it is continuous at this point. So where it is becoming integer, it is continuous at that point as well. That's why I said these will be point of consideration, not point of discontinuity. You will consider at that point, but it might be continuous, it might not be continuous as well. So total points are coming out to be 8. If I had blindly thought, then what answer I would give 1, 2, 3, 4, 5, 6, 7, 8 and some 9 points. But this pi is different. This pi is saying that yes sir, you will consider me, but you will have to check. So all these 9 points I would take and I would check at all the points. I would get to know that this pi is saying that even if you take value ahead of me or you take value below me, I will throw the same value, and I am throwing the same value at this particular point as well. What does that mean, sir? It is again coming out to be continuous only. Okay, this value was minus 2 here. So it is coming out to be equals to, it is coming out to be continuous only. So pi is not discontinuous, it is continuous. So that was the beauty of this question. It was a J advanced problem. Okay, it came in J advanced only. So is that understandable to you? This is how I will make the graph, and I will be able to make a comment on discontinuity. How I am able to make the comment on discontinuity, is that clear? Absolutely sir, it is clear. Although these kind of like this is not considered as very tough question. Surely it is a tough question, but not very tough. So this is how you need to think, sir. Between 2 to 1 it will be mapped to 1, between 1 to 0 it will be mapped to 0, between 0 to minus 1 sir it will be mapped to minus 1. Here it will be mapped to sir minus 2 only, then it will be mapped to 0, then sir it will be mapped to 0, then it will be mapped to 1, and then last value sir 2 only. So at boundary points they are breaking, and in between sir 1, 2, 3, 4, 5 and 6. At 6 points they are breaking and 2 boundary points they are breaking. That means sir total answer would be 8. Here I explained, that's why I took time. In the examination you can think in a much quicker manner. Is that understandable to you? Clear? Let's move to the next question. For if the function is like this is important. Okay, I would say this is important. These kind of questions are asked in the GATE examination again and again. So if the function is like this and they are asking find out the point of discontinuity, then you will check where the definition is changing. Again and again I am saying the same thing, where the definition is changing. So let me know where the definition are changing. So sir, definition is changing at 0, it is changing at 1, it is changing at 3. Along with that you need to check this guy as well, because what this guy says that when I am integer, what this guy says that when I am integer then I create problems. So if x is between 1 to 3, then you will follow greatest integer function of x. That means what will be your matter of concern? From here the matter of concern will come out to be x equals to 2, because x cannot take the value 1, x cannot take the value 3, only x can take the value 2. So you will check at 2 as well, and rest all guys are fine. Rest all says that I am always continuous, this is always continuous, this is always continuous. You draw the graph of mode of x plus 1, this is the graph. You draw the graph of y equals to x, this is the graph. You draw the graph of this guy always creates problem, and x minus 1, this is the graph. All are always continuous, they don't create any problem. But he says that I will create the problem when I am equals to 2. So these are the points of consideration. These are the points of consideration. These points I will consider these points. That means if I don't draw the graph, without drawing the graph, if I solve this question, what I will do, I will find out the value of f of 0. So f of 0 is followed here, value is 1. Then I will find out the value of f of 0 minus. 0 minus means I will follow this definition. So if I put 0 here, value I am getting is 1 only. And then I will calculate f of 0 plus. F of 0 plus means I will put the value, f of 0 will be lying in this range, So I will put x equals to 0 here, value I am getting 0 only. That means it is discontinuous. So my doubt was that it could be discontinuous. Actually it is discontinuous only. So yes, at x equals to 0 it is discontinuous, right? Now I will check at x equals to 1. So let's check at x equals to 1. So if I calculate f of 1, which definition I will follow? This definition I will follow. You see the equal sign, no? If I calculate f of 1 minus, then again sir I will follow that same definition. The graph is equals to x only, the value will be x, the value will be 1. And if I follow f of 1 plus, so 1 plus means I will have to go to this guy, and what this guy is saying, whatever the value is there, do 1 plus means 1.0001, and it will just map it to just lesser integer. So what is the answer you are getting? 1 only. What does that mean? This is not discontinuous, or you can say it is continuous. So this was our doubtful guy, but when I talked to this person, he said that no issue bro, I am continuous. He was doubtful, but later he was proved innocent. Okay, so yes, it is continuous. What about the other guy? Other guy is 2, and it is pretty obvious. If I go and ask what is the value of f of 2, he will say I am 2 only. If I go and ask what is the value of f of 2 plus, he will say okay, just greater than 2, again 2 only. And what is the value of f of 2 minus 1.999999? It is 1 only. What does that mean? Discontinuous. So 2 was our doubt and he has cleared the doubt. Yes sir, I am doubtful and your doubt was correct only. What about 3? If I go and ask what is the value of f of 3? Where is the equal sign? Here is the equal sign. So 3 minus 1 will be equals to 2. What will be f of 3 plus? 3 plus means this will be followed. Again 3 minus 1 will be equals to 2. And what will be 3 minus? 3 minus means here I will have to go. 3 minus means 2.9999 something. And where it will map? Just lesser integer, that means it will map it to 2. So you were doubtful, but again it is coming out to be continuous. So what all are the point of discontinuity? Only 2 points are point of discontinuity. So what all points are points of discontinuity? Sir, only 2 points which are x equals to 0 and 2. Only 2 points are points of discontinuity, x equals to 0 and 2. This is the answer. So all the doubtful points I will write down, and then what I will do is that I will simply check at all these points, and then I go to know that point of discontinuity was only 2. 4 points were doubtful, but 2 were proven innocent, 1 was proven innocent, and 3 was also proven innocent. And how will I get to know that which point I need to consider? What I will see is that where the definition is changing. So definition is changing at 0, 1, 3. And then I will see, okay, greatest integer function. So I will have to go and talk to him that when you become integer, he will say when x is equals to 2, at that time I will become integer. So 2 will also be my matter of concern. Okay, so 2 and 0 was the problem. Now what I will do is that I will draw the graph. Can I draw the graph? In a bit quicker manner I will draw the graph because enough practice we have done. Okay, bit quicker manner. So this is your x equals to 0. So what is the scenario for x less than 0? The scenario for x less than 0 is that you will follow the graph of mod of x plus 1. What is the graph of mod of x plus 1? So the graph of mod of x plus 1 is somewhat like this, sir. Somewhat like this. But you will follow it. This is the graph, sir. This value is minus 1, sir. This is the graph. But you will follow it only for what point? Only till the point of x equals to 0. That means for x less than equals to 0 it will be followed. That means it will be followed till this point only. So at minus 1 it is throwing value 0, at 0 it is throwing value 1. At 0 it is throwing value 1. After that what you need to follow? Between 0 to 1, between 0 to 1, between 0 to 1, sir, I need to follow the graph of y equals to x. Then this is how the graph would go. This is how the graph would go. Y equals to x graph I need to follow. Just make sure one thing, that at x equals to 0 the value was 1. At x equals to 0 the value was 1. Why is that so? Because it was following the previous graph. It was following the previous graph. It was following this graph. It was following at x equals to 0 it was following this graph. So this kind of graph you will be getting between 0 to 1. So at 1 there is a equal sign, that means here the value will be 1 only. So I will make a dot here, not the bubble. Now after 1 what will be the scenario? After 1 our good guy will come into action. So if the value is between 1 to 2 and 2 to 3. So if the value is between 1 to 2, what he will say? I will give the, if you put between 1 to 2, let's say 1.99 I am putting, so he will give the value to be 1 only. So till this point he will give the value to be 1, and after that what he will do? If the value is 2 or greater than 2, then he will give the value to be 2 only, right? So this is the greatest integer function graph we are drawing, which we already know. So here he will give the value to be 2, and here till this point I don't know what value this 3 will take. So after 3 what is the scenario? From 3 to infinity the scenario is x minus 1. So at 3 he will give the value to be 2. At 3 he will give the value to be 2. And what is the graph of at 3 is giving the value to be 2. And what is the graph of x minus 1? The graph of x minus 1 would be somewhat like this, right? Positive slope. So the graph of x minus 1 would go on like this. There you go. Is that clear to you? So this is the graph of fx you are getting. Drawing the graph of x minus 1, it is very easy, no? Put x equals to 3, what you are getting? 2. Put x equals to 3, you are getting 2. Put x equals to 4, what you are getting? 3. At 4 you will be getting value 3. Then at 5 you will be getting value 4. At 6 you will be getting value 5. At 7 you will be getting value 6. In that manner the graph will keep on going, right? What does that mean? The graph is breaking at 2 points, at this point and at this point. So they are the point of discontinuity. So if you could draw the graph, then this is how you could check. Otherwise you go on asking them that where the definition changes, you are my matter of concern, you are becoming integer, you are my matter of concern. I will check at all those points and I will get to know that discontinuity is there at x equals to 0 and at x equals to 2 only. Either you draw the graph, or if you don't want to draw the graph, then you solve in this manner. Absolutely, completely clear, completely understandable as well. Say yes or no, right? Okay. So let me take a break. You try solving these questions. What this question is saying, very simple concept is there. If fx is equals to gx by hx, no, then fx will be discontinuous for all the values such that hx is equals to 0. Is that clear to you? If hx is becoming 0, then the graph will be discontinuous. Understandable? Given that both gx and hx are continuous, given both hx and gx are continuous, what is the meaning of this sign? This sign is for all. This is the meaning for all. For all, okay, are continuous for all x, for all kind of x, for all x belonging to real values. For all the real values of x, I am saying that gx and hx both are continuous. And I have told one thing, that polynomials are always continuous. Did I say this thing? Again I am writing down polynomials. Do you know what is polynomial? Yes sir, we have drawn the graphs of polynomial. So when we were drawing the graph, what kind of graph you were getting? Somewhat like this. In this kind of graphs you are getting, no? So these graphs are never breaking. So all the polynomials are always continuous. Polynomials are always continuous. Polynomials are always continuous. Basically the point is, let's just say hx is discontinuous at some point. Okay, let us say hx is discontinuous at some point. So if hx is discontinuous, then fx will be by default discontinuous, no? Are you able to understand this point? Are you able to understand what I am saying? Right? And if gx is continuous, then if gx is discontinuous, then by default fx will be discontinuous, no? But if it is gx by hx, then what will be the scenario? If this guy becomes 0, if hx becomes 0, then what will happen? If hx becomes 0, then what will happen is that gx will tend to infinity. If hx becomes 0, then gx will tend to infinity. What does that mean? Sorry, not gx, sorry guys, sorry, big blunder. Then fx will tend to infinity, right? If hx is 0, then fx will tend to infinity. That means fx will become discontinuous. So just if these kind of values are, if these kind of questions are given, just put the denominator equals to 0. So denominator equals to 0, that means at x equals to 2, the fx will be discontinuous. Fx will be discontinuous. That's it. This is the answer. Now what some intelligent student would say, that sir, this is my fx, no? X square minus 4 x minus 2. So x plus 2 x minus 2, so divided by x minus 2, a square minus b square I applied. So this and this is getting cancelled out. Fx equals to x plus 2. So sir, I have done fx equals to x plus 2. Now sir, if I put f of 2 here, sir, what is the answer I am getting? 4. Sir, you are saying it will be discontinuous. I am getting the perfect answer. Sir, here if I put 2 plus, what answer I am getting, sir? 4 only. 2 minus, I am getting the answer to be 4 only. How you are saying it is discontinuous? Sir, it is continuous only. Whatever the process that you have done here, that is wrong. Why is that so? Just as you cut down here, what you need to write down? X cannot be equals to 2. So this 4 value that you have find out, they are correct. These values are correct. Limiting values are correct. When you wrote down this particular thing, that fx equals to x plus 2, at that time you have made sure one thing, that x cannot be equals to 2. Why is that so? Because if I find out the value of f of 2 here, what will be the value? 2 square, 4 minus 4 divided by 2 minus 2. So they are 0 divided by 0. This is not indeterminate form. They are exact 0 divided by exact 0. What does that mean? That means f of 2 is nothing but exact 0 divided by exact 0. And what is the meaning of exact 0 divided by exact 0? The meaning of exact 0 divided by 0 is undefined. So f of 2 is actually undefined. So what kind of graph you will be getting? If you draw the graph of this fx, what kind of graph you will be getting? So the graph will be nothing but, sir, x plus 2. What is the graph, sir? X plus 2. Yes, the graph will be like x plus 2 only. The nature of the graph will be like x plus 2 only. This is how the graph would look like. But at 2, it will be breaking. So this kind of graph you will be getting. When x is equals to 2, it will break. When x equals to 2, it will break. At x equals to 2, it will break. So this will be your graph. You can draw in any simulating software. You can see the graph will look like this, but here at 2 there will be bubble, because at 2 the value is not even defined. Someone would do this process, he will say the value will come out to be 4, absolutely baseless. F of 2 plus is 4, f of 2 minus is 4, but f of 2 is undefined. Yes, the graph will be x plus 2 only, but all the values, but not x equals to 2. So at a lot of places I have seen that what they would do is that they will cancel out and they will say that yes, x plus 2 is always continuous, baseless. If the question is given gx by hx and you get to know that gx is a polynomial, hx is a polynomial, they are always continuous, then simply put hx equals to 0, your job would be done. Simply put hx equals to 0 and your job would be done. You will be able to find out the point of discontinuity. Let's just solve this question. Find out all the points where your function is discontinuous. Okay, all the points you need to find out where your function is discontinuous. What is this? What is this OW? This is otherwise. Otherwise means if your x is greater than or equals to 2 pi or x is less than equals to 0, then value is minus 2. And if x is between 0 to 2 pi, then this is the value. So what I mean to say is that they are saying my graph is somewhat like this. My graph is somewhat like this. This value is 0. This is your 2 pi. So if the value is greater than 2 pi, then answer you are getting is minus 2. Then answer you are getting is minus 2. Here you are getting the value to be minus 2. And if it is less than 2, if it is less than 0, then also you are getting the value to be minus 2. Now in between here some graph you will be getting. Here some graph you will be getting. What kind of graph you will be getting, that you don't know. Now for this graph I know one thing. For 1 divided by mod of sin x minus 1 by 2, mod of sin x minus 1 by 2, I know one thing, that it will be discontinuous. It will be undefined, or I can say discontinuous when mod of sin x minus 1 by 2, when the denominator is equals to 0, or you can say mod of sin x is equals to 1 by 2. So whenever your mod of sin x is coming out to be 1 by 2, at that point it will be discontinuous, or at that point it will be throwing the value undefined, or you can say undefined only, you can say, right? If your mod of sin x minus 1 by 2 equals to 0, at all those x it will be throwing the value to be undefined. Basically now I need to find out all the values of x for which mod of sin x is equals to 1 by 2. So can I draw the graph of mod of sin x? Can I draw the graph of mod of sin x or not? Absolutely sir, I can draw the graph of mod of sin x. If I draw the graph of mod of sin x, then sir, this is how it will look like. And I only need to care about x belonging to 0 to 2 pi. What I need to care about? Between 0 to 2 pi only. So between 0 to 2 pi only I need to draw the graph of mod of sin x. So this is the graph of sin x, no? Between 0 to 2 pi. This is the graph of sin x between 0 to 2 pi. Now I need to care about the graph of mod of sin x. Then what will happen? This negative value will become positive value, right? This negative value will become positive value. This is the graph of mod of sin x. So how many points are there? How many points are there where what is this value? This value is 1. So how many points are there where the graph is throwing value 1 by 2? How many points are there such that the graph is throwing value 1 by 2? So let's make it a bit better. Okay. So this upper value is nothing but 1. Can you let me know how many points will be there where the value will be 1 by 2? So I need to find out all the points where the value is 1 by 2. So all the points will be these points. What all are those points that I don't need to care, but I will write down those points as well. Okay. So all these points the value will be 1 by 2, because I need to find out all the values of x where the value is 1 by 2. So what all values that would be? What is this point? Sine 30, right? Pi by 6. What will be this point? Pi minus pi by 6, that will be 5 pi by 6. What will be this point? Pi plus pi by 6. Am I saying it correct? Pi plus pi by 6. Sine pi plus pi by 6. Yes. And mod is there, no? Yes. So pi plus pi by 6. So this will become 7 pi by 6. And this will be 2 pi minus pi by 6. What does that mean? What is the value of 2 pi minus pi by 6? That will be 11 pi by 6. So these are the 4 points where the function would become undefined, where this function would become undefined. What I mean to say is that 1 divided by mod of sin x minus 1 by 2 will become equals to undefined for what all values of x? For x equals to pi by 6, 5 pi by 6, 7 pi by 6 and 11 pi by 6. So these are the point of discontinuity for fx. These are the point of discontinuity for fx. But you will always should check at the boundary points as well where the definition is changing. Okay, no matter whatever the question is there, always check at the boundary points where the definition is changing. What I mean to say is that I know, sir, value of f of 0 is minus 2. Sir, I also know the value of f of 0 minus as well. Sir, that is also minus 2. But sir, I need to check the value of f of 0 plus as well. What that value will be? Sir, 1 divided by sine 0 plus minus 1 by 2. Sine 0 is 0 only. So answer is coming out to be minus 2. It is continuous. And then I will check at 2 pi as well, because at 2 pi as well the definition is changing. What is the value at 2 pi? The value is minus 2. What is the value at 2 pi plus? The value is minus 2 only. And what is the value at 2 pi minus? The 2 pi minus 1 divided by sine 2 pi minus 1 by 2. So sine 2 pi is 0 only. You know the graph of sine 2 pi, right? Sine 2 pi is nothing but 0. 2 pi minus value will be nearly 0 only. So this value is also nearly 0. So answer is minus 5 by 2. So it is continuous at 0 and minus 2. Basically the graph would be, I don't know what will be the nature of graph here. I don't know what kind of graph I will be getting. Okay. But I am pretty sure about one thing. What do I know? That there will be 4 points where the graph will give you undefined values. There will be 4 points. There will be these 4 points, pi by 6, 5 pi by 6, and then 7 pi by 6 and 11 pi by 6. At those 4 points, they will give you undefined value, and rest everywhere the graph will be defined and continuous. Okay, so 4 will be undefined points. Then the number of points at which the graph fx is discontinuous, the answer is 4. I know these are not very straightforward question, but complete intuition I am giving you how to solve these problems in the examination also. Draw the graph. If you are able to draw the graph, no, then there is no issue. If you are able to draw the graph, there is no issue. Otherwise, all the boundary points where the definition is changing, I will check. This is integer, I will check. And for signum, when it is becoming 0, I will check. That's it. For signum, where the function inside function is becoming 0, that point I will check. If the function is integer for greatest integer function, then I will check. And here for gx by hx, if hx is becoming 0, then that will create the problem. So where this guy is becoming 0, at those point I will check. I don't even need to check where it is becoming 0. For sure it will be discontinuous, because it will be throwing the value undefined. If this is 0, it will be throwing the value undefined. So now I got to know that my target is that I need to find out all those x where sin x is becoming equals to, mod of sin x is becoming equals to 1 by 2. Okay, and I only need to care about between 0 to 2 pi only. So there are 4 points like that. They are making sure that this is going towards infinity. 1 upon mod of sin x minus 1 by 2 is going towards infinity. So 4 points are there. So answer will be total 4 points. Understandable? Very good question. If you just solve in your rough notebook, then you will be able to understand. Otherwise, you will just keep on looking. Okay, so you should be working in your rough notebook. Then only you will be able to understand mathematics. If you are just looking at the screen, then you will not understand anything. Do the rough work. If I was teaching every straightforward thing, no, let's just say how this topic is taught. Limit x tending to 0 plus f of a plus h minus f of 0, find out the value, then find out the limit. This is how this topic is taught. But you are engineers. You are not a class 11, 12 guys. Right? You are not a 17 or 18-year-old student. You are 21, 22-year-old guy or 20-year-old guy. So I know how to teach the engineering. I am teaching you the engineering, not that usual mathematics you see. Okay, so you can appreciate it and you can have some concentration as well, because if the lecture is of 3 hours, that means you would require the attention of 3 hours. If you cannot have the attention, like even for 1 minute, if you lose the attention, no, then you will not understand anything. So that kind of content I make. Okay, so those limit x tending to 0 plus, all those things I will not teach. I need to teach the engineering part. I am teaching the engineering part only, and using my problem solving skills, using my concept, using my intuition, there wouldn't be a single problem that you will not be able to solve. Every single problem you will be able to solve. Are you able to understand this point? Okay, so yeah, this is how we are going to solve these kind of problems. Next question. Discuss the point of discontinuity. Where it will be discontinuous, sir? When the denominator becomes 0. So point of discontinuity would be at all those points where the denominator is becoming 0. Now I will have to take two cases, because I know that, sir, mode of x is opened in two different ways, no? Basically, if x is greater than 0 or equals to 0, you can say, then mode of x will be opened as x. And if x is less than or equals to 0, then mode of x will be opened as minus x. So two different cases I need to take. So here I am taking this case. So what answer I will be getting? And here I will be taking this case, x square plus 3x plus 2. So if you solve it, what you get? X minus 2, x minus 1, right, equals to 0. And here what you will get? X plus 2 and x plus 1. So what points you are getting? 1, 2. And here what points you are getting? Minus 1 and minus 2. So at 1, 2 and minus 1 and minus 2. At 1, 2 and minus 1 and minus 2, these are the point of discontinuity. Points of discontinuity. Points of discontinuity. So how many total points are there? Total points are 4. Discontinuity. So total number of points are 4, and what all points are there? 1, minus 1, 2, minus 2. Where the denominator becomes 0, just as you see fx by gx or hx by gx, whatever, or gx by hx, just put denominator equals to 0, your job is done. Nothing else you need to think. But make sure one thing, that both of them are continuous. X equals to 1, this graph is always continuous, no? This is a DC value. And this x square minus 3x by 2, this is a polynomial. This is also always continuous. So this graph is always continuous, this graph is also always continuous. So I need to make sure one thing, that denominator goes to 0. If denominator goes to 0, 1 by 0 will be undefined. So wherever the graph is becoming undefined, those will be the point of discontinuity. So point of discontinuity are minus 1, minus 2, minus 1, 1 and 2. So what all are the point of discontinuity? Minus 2, minus 1, 1 and 2. These are your answers. Okay, well and good, very simple thing. Now I guess we are left with the last topic, continuity of composite functions. So now I need to take a break and then I will come back. We will discuss the continuity of composite function. You try doing it on your own. Like, let me know if fx is always continuous or gx is always continuous, or at what point they are discontinuous, and then find out the value of fog of x and gof of x, and then let me know at what points they are discontinuous. Okay, everything try doing it on your own, and then we will build up some method, and this point will also be completed. So one question, and I guess 2 and 3. 3 questions we need to solve, and then our chapter will be, then this topic will be completed, which is continuity. So let me take a break and then I will come back. Yeah, welcome back. So did you try this question? Okay, let's get started. So first let's talk about fx. What we are talking about? We are first talking about fx. So in fx, sir, when it will be discontinuous? When the denominator becomes 0. That means x minus 1 becomes 0. That means, sir, x equals to 1 will be the point where it will be discontinuous. Understandable? Very straightforward. Similarly, you can write down for gx as well, right? So similarly, for gx, if I write down, then, sir, when the denominator becomes 0, at that time, sir, it will be discontinuous, right? So this is for gx. Now, sir, what about f of gx? F of gx. Let's talk about f of gx, or I can say f of gx. What is gx? Gx is nothing but 1 upon x minus 2. So in place of x, you need to put 1 upon x minus 2. Look, you should not be solving further. Here only you need to tell the point of discontinuity. What I mean to say is that, let's just say I solve it further, then what answer I will be getting? Sir, answer I will be getting is x minus 2 plus 1, right? So it will be x minus 1 divided by minus x plus 3, right? Minus x plus 3, if you solve this one. Now from here you will say, what you will say? That, sir, it will be discontinuous at x equals to 3 only. This will be your answer. But it is wrong. Why is that? Why is that so? Because you have cancelled x minus 2 to x minus 2, no? Basically, how you would have solved it? 1 plus x minus 2 divided by x minus 2. Then, sir, 1 minus x plus 2 divided by x minus 2. So this you would have cancelled, and then you would have written x minus 1 divided by minus x plus 3. So you cancel this, no? X minus 2 and x minus 2 is getting cancelled, right? So when you cancel them, what does that mean? Just as you cancel them, you would have written no, that x should not be equals to 2. Basically, if you just see this expression, if you see this particular expression, or so here what you would understand, that if I put x equals to 2, then what will happen is that this will become 1 by 0, that will be undefined. This will also become 1 by 0, that will be undefined. So better than looking at this particular expression, we need to look here only. So what we will do is that I will say, from here I will say and say that first matter of concern will be that x minus 2 becoming 0. X minus 2 becoming 0, that means x should be equals to 2. This will be the first matter of concern. And what will be the second matter of concern? The second matter of concern would be 1 upon x minus 2 minus 1 becoming 0. So from here what you will see, x minus 2 equals to 1, or you can say x equals to 3. So two matter of concern are there, x equals to 2 and x equals to 3. That means 2 points will be there where the function will become discontinuous. Is that understandable to you? 2 and 3 are the 2 points. Okay, so the final expression might be giving different results, so they are not giving the correct result. Okay, final expression will not give the correct result. How will you get the correct result? Just as you have put up the value, that's it. On the very next step, gx, put the value, and then on the very next step you need to give the answer. Understandable? Try getting the correct answer for g of x. What does that mean? Try getting the correct answer of g of fx. Can you try getting the correct answer? Yes sir, g of fx I need to do. What is fx, sir? Fx is nothing but x plus 1 divided by x minus 1. So here what I need to put, 1 upon x plus 1 upon x minus 1, and here there is minus 2. So just as I have put up the value, from here I need to give the result, not from the final answer. So from here I need to give the result. What I will say, sir, I will look at the denominator here. So this denominator will create the problem, that means x minus 1 equals to 0. So sir, this is creating a problem. Although in the examination we will solve by a different method, but I am telling this method here. So sir, x minus 1 will create a problem. Okay. Along with that, who will create the problem? Sir, x plus 1 divided by x minus 1 minus 2 becoming 0. So this will also create a problem. That means x plus 1 equals to 2x minus, this 2 goes here, so it will become 2x minus 2. So this will come out to be x equals to 3. So two guys are creating the problem, x equals to 1 and x equals to 3. So here this will be discontinuous at x equals to 1 and 3. Understandable? This was discontinuous at 2, 3, and this is discontinuous at 1, 3. But this is how we are not going to solve in the examination. There will be some method 2 as well. Some different method has to be there. So what you will do? First of all, you will write down your fear. What is your fear? What does that mean? I know that, sir, this function fx will become discontinuous at x equals to 1. That means my fear is f of 1. And this will become discontinuous at x equals to 2. That means my fear is g of 2, right? X equals to 1 and x equals to 2. That means what is your fear? Your fear is f of 1 and g of 2. These two are your fears. Okay, these are your fear, f of 1 and g of 2. Now let's talk about g of fx. Okay, I am talking about g of fx. First of all, what I will do, I will go to this function f and I ask you what should be there inside you such that you will give discontinuous function. So here I will say that if x is equals to 1, from here only I am getting to know that if x is equals to 1, then there is a concern. What I mean to say is that if I put x equals to 1 here, then what I will be getting? G of f of 1. G of f of 1. And what is f of 1? You know that, sir, f of 1 is nothing but undefined. Undefined. So anything undefined, like whatever that is written inside, that is also undefined. That means this will also become undefined only. No? Are you able to understand this point? So first of all, I will go inside and ask him what is the matter of concern. He will say, sir, x equals to 1 is the matter of concern. That means yes, x equals to 1 will be one of the point of discontinuity. Now what would be the other point? Now I will ask G and I will ask him what is the matter of concern for you. G will say the matter of concern is g of 2. That means inside me, if 2 is there, then there is a problem. So what is the function? The function is g of fx. Now this g is saying that inside me, if there is 2, then there is a problem. What does that mean? If fx equals to 2 is there, then there is a issue. Are you able to understand this point? If I put this fx equals to 2, then there is a issue. Then the function would become discontinuous. What I mean to say is that g of 2 I am putting. That means g of fx being equals to 2. I am talking about what I am talking about. I am talking about g of fx. What I am talking about? I am talking about g of fx. I am talking about g of fx. So what I am saying is that if I put fx equals to 2, then g of 2 will be there, and this will be the problem. Here the function will become undefined. So what does that mean? Who is an issue? Fx being equals to 2. What is fx? Fx is nothing but x plus 1 divided by x minus 1, that is being equals to 2. So what answer you are getting? X plus 1 equals to 2x minus 2. So value of x is coming out to be 3. So there are 2 points of discontinuity, that is x equals to 1 and 3. So this is how we will be solving. The same answer we are getting. So just first go to the other function, then ask him who is the matter of concern, then go to the other function and ask him who is the matter of concern, who is your fear. Let's try for f of gx as well. F of gx. Okay. Let's try for f of gx. So what you will do for f of gx? Sir, f of gx could be written as f of gx in this manner. Now I know that who are my matter of concern. F of 1 and g of 2 are the biggest issue. F of 1 and g of 2 are the biggest issue. So I will go here and I will ask him what is the problem for you. He will say x equals to 2 is the problem. That's it. Now I will go and I will ask him who is your problem. He will say f of 1 is a problem. What he will say? Sir, in f of gx, f of 1 is the problem. What does that mean? That means, sir, gx equals to 1 is a problem. Gx equals to 1 is a problem. What is gx? Gx is 1 upon x minus 2. Gx is 1 upon x minus 2. That should be equals to 1. So who is the problem? X equals to 3. So first I went to f of gx. Okay, then I asked g who is the problem for you. G will say that g of 2 is a problem. So when you will get g of 2? When x is equals to 2. Then I go to f and I ask you who is the problem. He will say f of 1 is the problem. That means gx being equals to 1, that is the problem. That means x equals to 3 and x equals to 2 are the issue. X equals to 2 and x equals to 3 are the issue. Is that understandable to you? Understandable? So we are not writing down any conclusion or anything like that. You would have understood the concept. What does the concept say? I hope that is absolutely clear to you. Okay. So what I am saying is that let fx is discontinuous, or I don't need to write down all these things. Okay. Just I am writing down all these things. Like here I could create some theory, but that theory will not be useful for you. You just need to think. Okay. You just need to think who all are my matter of concern. Based on the matter of concern, I will put up the values and I will get my answer. We will solve more examples. It will be more clear to you. Let's try solving this one. You need to find out the number of points where y equals to fx is discontinuous. First, let me know, is the y function of t? Here what I can see is that, sir, y is a function of t. How they are saying y is a function of x? Because t is a function of x, no? T is a function of x and y is a function of t. What does that mean? Y is eventually the function of x. Y is eventually the function of x. So yes or no? But are you going to find out the function? No. What you will do? You will go to y. What you need to find out? Where y equals to fx is discontinuous. If they have put a f here, so I will put a h here. H here. Here I am putting h. So what I am getting here? H of gx. Now this h of gx they are replacing with fx. So this is what they are saying. So first of all, what you will do, you will go to y and you will ask him what is your matter of concern. Y will say where I can be discontinuous. So I will go and ask y where he can be discontinuous. He will say if my denominator equals to 0. I will solve it and I will get two answers, 1 and 2. Right? Or am I incorrect? 1 and minus 2. 1 and minus 2 will be the answer I will be getting. 1 and minus 2. Okay, so these two are the matter of concern. So he will say that I will not accept t being 1 and minus 2. Why is saying that? Why is saying that? Why is saying that I will be discontinuous if t equals to 1 and minus 2. Now if t is equals to 1, what is t equals to? T is equals to x minus 1. So if t is equals to 1, then what will be the value of x? The value of x will be equals to 2 only. The value of x equals to 2. Right? And if t is equals to minus 2, then what will be the value of x? Then value of x will be equals to minus 1. not minus 1. Let's solve it. X minus 1 will be equals to minus 1 by 2. So the value will come out to be x equals to 1 by 2. Say yes or no. So it will be discontinuous if t equals to 1 and t equals to minus 2. T equals to 1 means x equals to 2. And t equals to minus 2 means x equals to 1 by 2. So these are the point of discontinuity. That's it. Basically, I need to find out when the y will be discontinuous. So sir, y will be discontinuous if t is equals to 1 and t equals to minus 2. Okay sir. Now, but they are asking the value of x. So if t is equals to 1, what is the value of x? Value of x is 2. And if t is equals to minus 2, then what is the value of x? The value of x is 1 by 2. That means y will be discontinuous at x equals to 2 and 1 by 2. That's it. Okay, just from here to here we have got the answer. Very simple thing, very straightforward. Okay, last question of our continuity topic. Okay, 10 questions are there, 10 functions are there, and it will be completely revised now. And this point I have already said that all the rational functions are always continuous. So for fx, what is your fear? You will say no fear. No fear. Basically, I write down the fears. Who are the fears? What fx will say? Sir, I am always continuous. Always continuous. Why is that so? Because it is a polynomial of second order, or so I should say polynomial of second degree. So it is always continuous. He has no fear. Gx is having fear? Yes sir. Gx is having what fear? That sir, denominator becomes 0. That means Gx is having a fear of g of 6. And hx is having a fear of h of 1. Sir, if denominator becomes 0, then there is a fear. That means x equals to 1 is a fear, x equals to 6 is a fear. So these two are the fears. Is that clear to you? Okay. Now let's talk about f of gx. So I went to f of gx. Okay. F of gx is nothing but f of gx. Right. Now I went to g and I asked him, what is your fear? He will say x being 6. He will say x being 6. Then this is one of the point of discontinuity. I will go to f and I will ask him, who is your fear? F will say, no one is my fear. No fear. No fear. He will say, none of them, no one is my fear. No matter whatever that is there inside me, I will always be continuous. What does that mean? This is the answer. That's it. First one is done. For f of gx, this is the answer. Let's take, this is your first one. Is that understandable to you? Only one fear is there. Only g is having the fear. G is saying that x equals to 6 is my fear. What f will say? No fear is there. Okay. Next one. G of fx. G of fx. First I will go to f. I will ask him, who is your fear? F will say no fear. Then I will go to g and I will ask him, who is your fear? G will say that g of 6 is my fear. What does that mean? F of x being equals to 6 is the matter of concern. F of x being equals to 6 is the matter of concern. What does that mean? That x square plus 3x plus 5 equals to 6 is the matter of concern. X square plus 3x plus 5 equals to 6 is the matter of concern. What does that mean? That means x square plus 3x plus 5 equals to 6. That will become x square plus 3x minus 1 equals to 0. So from here value of x we are getting is minus b plus minus under root b square minus 4ac upon 2a. So what is the answer we are getting? Value of x we are getting is minus 3 plus under root 13 by 2 and minus 3 minus under root 13 by 2. So what all are the point of discontinuity? So conclusion here is that for g of fx, the point of discontinuity are x equals to minus 3 plus minus under root 3 by 2. 2 points are the point of discontinuity. Okay, that's the answer here and this is the answer here. Okay, third one. F of hx. F of hx. F of hx. I will write down in this manner f of hx. First I will go to h and I will ask him, who is your fear? He will say x equals to 1 is my fear. If x is becoming 1, then that is my fear. So x equals to 1 is my fear. Then I will go to f and I will ask him, who is your fear? F will say no fear is there. So only x equals to 1 is the matter of concern. Next one. H of fx. H of fx. First of all, I will go to f and I will ask him, who is your fear? He will say no one is my fear. Then I will go to h. I will ask him, who is your fear? H will say that sir, h of 1 is my fear. H of 1 is my fear. That means fx being equals to 1 is my fear. fx being equals to 1 is my fear. So fx equals to 1, x square plus 3x plus 5, x square plus 3x plus 5 equals to 1. So what you are getting, x square plus 3x plus 4 equals to 0. So from here let's try finding out the value of x. So what is the value we are getting, minus 3 plus minus under root b square minus 4ac, b square minus 4ac upon 2a. What is this? This is an imaginary value, not a real value. It is an imaginary value because in the under root there is a negative sign, no? So not a real value. That means there is no real value of x for which the h of fx is discontinuous. That means what does that mean? It is always continuous. Always continuous. Continuous for all x belonging to R. Okay. That means for all the real values it will be always continuous. In the examination, if always continuous is written, by default you need to consider that they are talking about the real values only. So on the x-axis we will take the real values only, no? So they are talking about the real values only. So for all the real values, this function will be always continuous. Why is that so? I went to f, he said no fear. I went to h, he said that my fear is h of 1. That means when fx become 1, then that is a matter of concern for me. So what fx is saying, that I will never become 1. Can we draw the graph? You can draw the graph of x square plus 3x plus 5. You will get to know that you can never get the value 1. You can do it on your own. Can you draw the graph of x square plus 3x plus 5? Although it is not required here, but I am saying that x square plus 3x plus 5, if you draw the graph, what will be the differentiation? Differentiation will come out to be at minus 3 by 2. So after minus 3 by 2, you will get a positive and then negative. So the graph will go like this, right? So this is the minimum value that you will be getting. So at minus 3 by 2, what value you will be getting? 9 by 4 minus 9 by 2 plus 5. So what is the value we are getting here? 5 plus 5 minus 9 by 4. Okay, so 5.25 minus 2 point. Oh, so here is 4 to the 8, 1, 4 to the 8, 2.25. So answer is 2.75. So the minimum value you are getting is 2.75. 2.75. That's the value. And apart from that, graph is always upper side. So that's the minimum value that you will be having. That means the graph can never be equals to 1. Even if it was 2, then also it was not achievable. Even if it was 2.5, then also it was not achievable. The minimum value that you are getting is 2.75. What does that mean? That means the graph will never be discontinuous. H of fx will never be discontinuous. Is that clear to you? All good? All fine? Let's go to the next one. Fifth. What does our fifth question say? G of hx. G of hx. What I will say? Sir, G of hx. I will go and ask h, who is your matter of concern? H will say, sir, my matter of concern is x equals to 1. X equals to 1. So my matter of concern is x equals to 1. So this is one of the point. Then I will go and ask this guy, who is your matter of concern? So he will say g of 6 is my matter of concern. G of 6 is my matter of concern. G of 6 is my matter of concern. That means h of x being equals to 6 is the matter of concern. What is h of x? 1 upon x minus 1. 1 upon x minus 1 equals to 6 is the matter of concern. So x is coming out to be 7 by 6. Okay, so 2 points of discontinuity are there, x equals to 1 and 7 by 6. Very simple thing. Till this point you would have understood very easily, right? So h of gx. So first of all I will go to g and I will ask him, who is your matter of concern? G will say, sir, x being equals to 6 is my matter of concern. Then I will go to h and I will ask him, who is your matter of concern? Sir, he will say h being equals to, sorry, h of 1 is my matter of concern, right? Inside whatever, inside me, if there is 1, that is my matter of concern. What does that mean? That simply means gx being equals to 1 is my matter of concern. What is gx? Gx is nothing but 1 upon x minus 6. 1 upon x minus 6 is my matter of concern. That means x has to be equals to 7. So x has to be equals to 6 and 7. These are my matter of concern. 6, 7. Okay. 6, 7 is the matter of concern. Next, 7th one. So 6 and 7 are the point of discontinuity. Here 1 and 7 by 6 is the point of discontinuity. Here no discontinuity. Here x equals to 1. Here x minus 3 plus minus under root 3 by 2. And then x equals to 6 is the point of discontinuity. Let's talk about gx by fx. Gx by fx. So what is gx? Gx is, sir, nothing but 1 upon x minus 3. And what is fx? X square plus 3x plus 5. 1 upon x minus 6, and this was x square plus 3x plus 5, right? X square plus 3x plus 5. Okay, so here what you are getting, gx is 1 upon x minus 6 and fx is x square plus 3x plus 5, right? So now here who will the concern? When denominator becomes 0, that means x minus 6 becoming 0. What does that mean? X equals to 6 is the matter of concern. This is one of the point of discontinuity. And what is the other point? Other point is x square plus 3x plus 5 becoming 0. So from here, if you find out the value of x, what values you will be getting? So minus 3 plus minus under root b square minus 4ac divided by 2a. What does that mean? No such a real value, right? No real value. I mean, this part will never create any problem. Only he will create a problem. We have drawn the graph of this part as well. The values were always greater than 2.75. That means this will never become 0 actually. X square plus 3x plus 5 will never become 0. The values will be always greater than 0. Okay, so the graph will be always positive. If the graph is always positive, then what will happen? Then he will never create a problem. We are not concerned about positive or negative. We are concerned about graph being equal to 0. This graph will become 0 at x equals to 6, but this graph will never become 0. That means only the point of discontinuity is x equals to 6. So no matter whichever the kind of questions you are solving, you will be able to solve. Next one is fx by gx. Fx by gx. So what is fx? Fx is nothing but x square plus 3x plus 5. X square plus 3x plus 5 divided by gx. What is gx? Gx is 1 upon x minus 6. So what you are getting? X square plus 3x plus 5 multiply with x minus 6. What this will become? This will become a polynomial, right? When you solve it, you know that it will become a polynomial of degree 3. What does that mean? That means it is always continuous. Always continuous, right? Always continuous. Understandable? Straightforward, no? Right? Next one, hx by fx. Hx by fx. What is fx? 1 upon x minus 1. And what is fx? What is hx? 1 upon x minus 1. And what is fx? X square plus 3x plus 5. Now you know that, sir, this will never create any problem. Who will create the problem? Only x equals to 1 will be the issue. That's it, right? And next one is fx by hx. At this point, you would have understood that it will be always continuous, because what is fx? X square plus 3x plus 5 divided by hx, which is 1 upon x minus 1. 1 upon x minus 1. So answer you are getting is x square plus 3x plus 5 multiply with x minus 1. So it is a polynomial. What does that mean? Always continuous. That's it. All the 10 questions we have solved, and we have understood the complete concept as well. Everything is crystal clear. So did you understand the meaning of continuity? Continuity was very straightforward topic, sir. Very easy topic. Just I need to check the value at a plus, a minus, and check the value at exact x equals to a. If all three are coming same, then what will be the scenario? That it will be the continuous function. Otherwise, it will not be a continuous function. Okay. So basically, where the graph is breaking, no. At the point where the graph breaks, that will be the point of discontinuity. Otherwise, the graph will be continuous only. So here only I think I need to take care is where the graph would be breaking. That's it. Okay. Where the graph breaks, that is my matter of concern. So this much continuity is more than enough for your GATE examination. Okay then, yeah. Thank you very much. Happy learning. Let's meet in the next lecture. In the next lecture, we are going to study about differentiability. Okay. Thank you very much.